Okay, dear student, let's see what is there in this question. The instantaneous velocity is defined as displacement divided by time, the rate of change of position, the distance moved divided by time taken, and the rate of change of distance. Okay, so we all know that velocity is the rate of change of displacement, so of course it is not distance. So C is wrong and D is wrong. We are very sure about it, like C and D are wrong. Now these two options, A and B, actually both of them are correct. But in such a scenario, we have to choose, we have to pick one which is more correct. Okay, like which defines more features. So although both of them are right, but we have to go for the better answer from these two. Let's see. First of all, how is velocity defined? So velocity is defined as displacement divided by time. Displacement divided by time. Now this is of two types. So the first is called the average velocity. This arrow shows that I'm talking about velocity, not speed. That is why I've written the arrow, but vectors are not in your syllabus, so no problem. So the average velocity is taken as the total displacement divided by total time. So you can just write it like this: the total displacement divided by total time. This is the average velocity. So the option 1 says it is the displacement divided by time taken. So it can be taken as, yeah, it is correct, isn't it? How is instantaneous velocity defined? Let me tell you that also. So instantaneous velocity is written like this. So this delta is actually reduced, like delta t is taken to be a very small value, but the formula or the expression remains the same, which can be written in the terms of differentiation. But I know that calculus is not in your syllabus in physics, so worry not, but you know a bit of this in maths AAHL, so you know it already, a bit of it. So you just write instantaneous speed as dx divided by dt, where dt is a very small time duration. Just try to imagine there is a car which is moving at 100 kilometers per hour speed, but you're talking about 1 second time duration. What is the distance traveled by a car in 1 second? So that kind of a thing will give you the instantaneous speed or instantaneous velocity in the case of displacement, isn't it? So this is the value. Now if you go for A, which is displacement divided by time, it does not say whether you're talking about the average velocity or you considering the instantaneous velocity. Both of them are displacement divided by time, so A is not that very good an answer. But B, on the other hand, is rate of change of position, which literally transcends itself into the change in the displacement of the body. So it is the change in the position. So position, like instantaneously there is a change in position. So you're literally talking about the change in position. By the way, this is the very best definition for the displacement also. For the velocity. So people say that how do you define displacement, let's say? So people define displacement in various ways. Like people will say it is the shortest distance between the initial position and final position. But these are not the perfect definitions for displacement. The right definition for displacement is the change in the position, like where is your position, that is displacement. So what is the displacement of the body into different positions? It is the change in position. That is defined as displacement. But of course it is equal to the shortest distance between the two. But this definition is much better and authentic. So we will go for B. Definitely B is the correct answer. Okay, dear students, all the best. This is Professor Varun. Thanks for watching the video. Bye. More questions coming our way. Okay, dear student, let's see what is there in this question. The variation with time t for an acceleration a of an object is shown. That at time t is equal to 0, the object is at rest. What is the speed of the object at t is equal to 8 seconds? So, although the question is quite simple, like it is talking about the topic A1, which is kinematics. So on the surface, it feels like the question should be very easy, but this question is not that easy because it is having a bit concept here. Listen to me. The first concept that you must keep in your mind is graph is given here. So number one, when graph is given, you are not supposed to use the SWOT equation. It is usually find the area or finding the slope. Number two that you have to keep in your mind is that whenever you see a graph, you have to see for the acceleration first of all. Is acceleration constant with respect to time? Well, in this case, clearly not, because the graph is given, and so acceleration is not constant. In fact, acceleration is a variable. So it is clearly a non-uniform acceleration case. Now, when it is non-uniformly accelerated motion, your all the SWOT equations and all the equations that you have learned in the topic A1, they are redundant for you. You cannot be using any of it. So all these SWOT equations anyways you can't use in this question. So I told you two very important points. Number one, when the graph is given, it is more about finding the area under the graph and finding the slope. Number two, you have to find whether the acceleration is constant or not. Now in this case, acceleration is not constant. It means that you can't be using any formula from the topic A1. So of course you would be finding the area, or in some cases you would be going for the slope. So in this case, acceleration time graph is given and the question is literally about the speed or the velocity. So we just need to find the area of this. Like you can even remember it like acceleration is defined as v divided by t. So v is equal to a into t from the units and dimension point of view. So you would be multiplying area and time. It means you have to find the area here. So area up to 8 seconds. So it is this triangle that I have drawn. So you literally want to find the area of the triangle if you want to find the cumulative velocity here. So area here will be half into base into height. So height is also given as 8. Now, when you are picking some data from the graph, always be careful about the units here. Number one, the unit should always be SI unit. Many a times the length is given in centimeters and others, so you have to be very careful about it. So even here, the unit is SI, no doubt about it. Another thing that you have to keep in your mind is that many a times there is a multiplicating factor given here, like for example, acceleration multiplied by 10 raised to power negative 2. It is written in the units here. So usually students pick this value like it is 8, so you just go for half into 8 into 8 and you get the wrong answer. Why? Because you forgot to have the multiplicating factor in your calculation. But in this case, clearly there is no multiplicative factor, so that doesn't matter. So your answer will be 64 divided by 2 and that will be 32. And the unit will definitely be meter per second square. You can clearly see if you would be, meter per second. So you can clearly see if you find the area, half is a constant, 8 here is having a unit second, and this 8 is having a unit meter per second square. So this second gets cancelled out, so your unit is coming out to be meter per second. So we have done it from the unit point of view also. Hence your answer should be 32 meter per second, and absolutely correct. That is the correct answer for this question. This is how we do this question, dear students. So by the way, I have the mark scheme of this question paper also. So I know that the answer is B, but I'm not showing it here. Okay then, all the best. Bye. Okay, dear student, let's see what is there in this question. A force X on a cube of mass M that accelerates upwards. Okay, so it is already given here that it is already accelerating. So if acceleration is not 0, it means F net will not be 0. So F net will be there. There will be some force will be acting upwards because body is going upwards, and that even it is accelerating. Along a vertical frictionless surface, the magnitude of the force is F, and it acts at theta to the vertical. So this is theta angle to the vertical which is acting here. So in these kind of cases, what we do is, number one, we have to create the components of the forces. So vector is not in your syllabus. So some schools are teaching vectors and some schools are skipping it. So let me tell you a bit of it. So what happens is, like, let's say there is this vector. So there are different physical quantities which are vector, like force is a vector, velocity, displacement, acceleration, momentum. These all are vector quantities, but energy is scalar quantity, work is a scalar quantity, mass is a scalar quantity. So these kind of like quantities, they are separated into two different lists. So every vector quantity is shown with an arrow on the head, but because they are not in your syllabus, so they might not be using the same in your IB questions and all. So the force, you have to remember, it is a vector. So we can divide it into this, like this is a triangle. So we just draw this triangle here. Like this. This is theta. So this component is written as F cos theta. The component which is adjacent to the angle is cosine, and the component which is perpendicular and in front of you, that is called sine theta. So F sine theta is in front of you and F cos theta is on the floor, like that. So you have to find like what is happening here. Like this is the force here. So first of all, I draw two components which are perpendicular to each other. So one will be here, another can be taken here. So this force component is along theta. So this will be written as F cos theta, and this can be written as F sine theta. It's a very simple thing. Like this is the perpendicular and this is the hypotenuse. So sine theta will be equal to perpendicular divided by hypotenuse, and you can literally find the value of the perpendicular because hypotenuse is given as F. So perpendicular becomes F sine theta. This is how we derive the component equation, by the way. So everything is given to you now. There should be no doubt about this. So this is F sine theta. So you are pushing the body into the wall with a force which is F sine theta. So what is this force doing? This force is creating a reaction from the wall. So this reaction that you are getting is technically equal to F sine theta. R is equal to F sine theta. Friction is not acting here. It is given frictionless. So it doesn't matter whether you are having the reaction or not. If friction was given there, we would be incorporating this and we will find friction also which is acting on it. So the friction Fs max would have been Fs into R, but now it is not there, so we are least concerned about it. So horizontal forces are literally not doing anything, only vertical forces will be accounted. So F cos theta is acting upward, and there is another force which is acting downwards, and that is the weight. So the body is overall going in the upward direction with an acceleration A. So the upward force is F cos theta, the downward force is mg. So F net will be F cos theta minus mg, and F net will be equal to m into a is equal to this. So acceleration will be F cos theta minus mg divided by m. So I don't have the space to write, so I'm just writing it like this. So this will be your answer, which seems to be the option A. So let me see, and absolutely correct option A is the correct answer for this question. And on it I told you in my video when students were going for the examination, a very funny thing, that if there is a typical question and you are not able to solve it and you think like, oh my god, this question is really giving me an extra headache, then usually the answer is A. So I don't know how correct is that, but if you have to guess it ever, you can go for A. In such kind of cases when you have to think extraordinary, usually the answer is A. Okay, dear students, so this is Professor Varun. Thanks for watching the video. Keep watching. Other videos are also coming your way. All the best. Bye. Okay, dear student, let's see what is there in this question. A sphere of density rho and the radius capital R rests on the bottom of a tank of water. The buoyancy force on the sphere is F1. Okay, so the buoyant force is F1. The sphere of the density twice of rho and the radius R by 2 is at the bottom of the same tank. The buoyancy force on the second sphere is F2. What is F1 divided by F2? Okay, so first of all, we have to be very clear about this thing, that let's say there is this water. The water's density is sigma, and this is the bottom. There is a sphere here which is having the radius R, and it is placed like this. So this sphere R is having the density rho. So first of all, as per the buoyant force is concerned, what is the expression for the buoyant force? The buoyant force is the volume of the body which is inside water into the density of water into the gravity. So it is not the density of body. So density of body doesn't matter. So this density of body which is written here, sigma rho and 2 rho, this actually sits here only for the confusion purpose. So according to my experience, IB usually don't do these kind of things, but this is a very tricky question. So they have given you an information which is not required in the question, which is an extra information. So B is equal to V in into sigma into G. Sigma is taken as the density of the water. I'm just taking this symbol sigma. You can choose any other symbol, by the way, no worries. This is the buoyant force. So now both of the bodies are now completely submerged. They are completely dipped. So 100% of their volume is dipped inside. So it is a total volume here. So the first buoyant force is given as F1. The volume will be 4 by 3 pi r cube sigma into g. And what about the F2? F2 will be 4 by 3 pi is just a constant. Now 4 by 3 pi r cube, the volume of sphere is given in your data booklet, by the way. So you can just take that formula from there. And the radius is r by 2. So you substitute r by 2 here, it becomes r cube divided by 8. That is 2 raised to power 3. And sigma remains sigma, g remains g. You just need to find the ratio of these two. So I can clearly see F1 divided by F2 will be equal to 8 because every other thing is the same. So you can even divide it on both sides. So it will become the reciprocal. Every other constant is getting cancelled out. Or you can say that you are going to substitute this much value as F1. So this becomes F1 divided by 8. So clearly F1 divided by F2 will be equal to 8. So either way, like that is just your algebraic sense, like what you are going to do here. So F1 divided by F2 will be equal to 8. And this is how we do this question. So very good. The buoyant force has been explicitly added into the new syllabus. So there you are. You can find the question here in the latest question paper. Okay, dear students, this is Professor Moon. Thanks for watching. All the best. Keep watching other videos. Okay, dear students, let's see what is there in this question. A satellite undergoes one circular orbit of Earth every 24 hours. Okay, what is the angular velocity of the satellite? Okay, so the question apart, by the way, these kind of satellites, by the way, there are different type of satellites. They are called geostationary satellite. Although you can say that there are two types of satellite. One is like equatorial satellites, those who are revolving only in equatorial plane. And the other satellite is which is moving from pole to pole. So they are called polar satellites. So these are two types of different satellites, and there are only two planes in which they are moving. Like one is like the polar plane, another is the equatorial. By the way, there can be many polar planes. Okay, and this kind of a satellite which is having a time period of 24 hours, they are given a special name which is geostationary satellite or geosynchronous. Like this information might help you for some of your extended essays or IEs if you want to give it a try. So it could be a good idea, by the way. So there are some satellites which are not supposed to go over the other countries. You know, like I'm sitting in India, let's say. So there is a satellite, a communication satellite, I would say, like we are using telecom communication and the cell phone communication, isn't it? So every country is having that kind of a satellite, first of all. So there is a satellite which is dedicated for this purpose. So it's not possible that Earth is moving and the satellite goes over to some other country. That is not allowed, because if Indian satellite is going over some other country, India is losing its communication. So that doesn't happen. Well, until the satellite is a military satellite. And those satellites are usually polar satellites which are used for snooping purposes in other countries, by the way. So if we even have those kind of satellites. So anyways, laughing, jokes apart. So these are the satellites which are revolving around the center of the Earth at the same speed, so that they are usually like at the same like over my head always. So the satellite which is over New Delhi, it will always be over New Delhi. It is not going to go to some other place. That is called geostationary satellite. For these satellites, the time period has to be 24 hours because even Earth is rotating in 24 hours. Otherwise, you just imagine satellite is not fixed in the space, isn't it? It can go anywhere, it can move anywhere. So how are we going to fix those things? So there is a certain orbit, there is a certain height. If to the best of my memory, it is 36,000 kilometers above the surface of the Earth that you find these kind of satellites, for which the time period is 24 hours, by the way. Okay, this is just an extra piece of information. What is the angular velocity of one such satellite? So the angular velocity of one such satellite, the time period is given. So I would say the time period will be 2 pi r divided by v, or 2 pi divided by omega. because you are supposed to find the angular velocity. Yes, so we will not even be talking about the tangential velocity, which clearly makes our calculations more cumbersome. So the question is made intentionally easier by IB examiners, I would say. So T is equal to 2 pi by omega, and by just doing one arithmetic function, you get the answer. That's it. So this is 2 pi divided by the total time period, which is 24 hours, and 1 hour is having 3600 seconds. So you divide by the total number of seconds that you want. So it is 2 pi divided by this. That should be giving you the correct answer. So let me find my calculator, and so there is the value. 2 pi divided by 24 divided by 36. I'm getting 7.27 something. So C will be the correct answer. Exactly, this is the value that I am getting. And now on it, you can just concentrate on the unit here. It is angular velocity. It is angle divided by time. So it is radian per unit time. So it is radian per second. Hence, the answer for this question is C. Okay, dear students, all the best. This is Professor Varun. Thanks for watching. Keep watching. The next question is coming our way. Okay, dear student, let's see what is there in this question. An object of mass 5 kg is initially at rest. An impulse of 2 Newton second acts on the object. What is the final kinetic energy of the object? So it's a very typical question, many a times asked by IB, I would say, and you can find impulse based questions on my YouTube channel. You can just search, like, write impulse Professor Varun, and you would be finding so many questions in the question bank itself. So you can give them all the try and you can learn the procedure. So the impulse, first of all, is defined as change in momentum. This J is an impulse, even that is a vector. Momentum is also a vector. Change in momentum can be written as the m into v final momentum, and this is the initial momentum. So in the case of impulse, momentums, and change in momentum, everything, direction plays a very crucial role. If the direction is becoming opposite, you have to incorporate the directions here, like positive and negative. That is why it is very important for you to incorporate the knowledge of vectors in these kind of things. But of course, they are not in your syllabus, so we can assume that they won't be asking you very difficult question from this. But again, that is just a chance. Okay, so 5 kg is the mass, and initially it is at rest, so the initial velocity is 0 anyways, and the impulse is given as 2 Newton second, and mass is 5 kg. So what is the final velocity that will be picked up by the body? It will be, like, Newton second is just the unit, so you can just remove it. It will be 2 by 5. So the velocity that the body gets is 2 by 5 meter per second. The mass is 5 kg. Now you can find the final kinetic energy, half into m into v square. So it is 2 by 5, 2 by 5, 5 and 5 gets cancelled out, 2 and 2 gets cancelled out. It is 2 by 5, so it is 2.0 divided by 5, which gives you 5 for the 20. 0.4 joule will be the correct answer. So A is absolutely correct answer. So this is how we do this question. Quite simple, by the way, but still tricky, I would say, still tricky. So try to do this question, try to learn this question. Find more questions on impulse on my YouTube channel. Okay, dear students, all the best. Bye. Thanks for watching the video. Bye. Okay, dear student, let's see what is there in this question. A system of moment of inertia I rotates from rest about a given axis. The angular acceleration alpha of the system is constant. What is the change in angular momentum when the system has made 4 complete rotations? Okay, this is a very difficult question, I would say. Immense. Couple of reasons. Number one, like this topic of inertia, the rotational body, earlier in the old syllabus, it was the part of optional engineering physics options. And so not every student was going to do this. It was not in your regular syllabus, but this time this topic has been added into your new syllabus. So there you are, you find the moment of inertia in IB's paper 1 kind of questions first time. And on it, the question is not easy because they are mixing too many things. Like they're talking about the moment of inertia, at the same time talking about alpha, and it is also given it is constant. They're talking about angular momentum on it, and on it they're talking about the angular displacement. There are many variables which have to be connected with each other. So I suppose this should be one of the most difficult question in this question paper. So let's see how to do this question. So my method of doing these kind of question is, first of all, think about, rather than thinking about the rotational dynamics, we would be thinking about the translational motion, and think what kind of formulas would you be using if it was translational. And then we think about what is the corresponding formula in the circular motion. That is how you think. So the moment of inertia is actually replaced with m. Acceleration is written with a, and it is given as acceleration is constant. Now it clearly makes sense. Why is it given that acceleration is constant? Something should be related with Stewart equations, because otherwise acceleration can have any value. Because it is given acceleration is constant, you would be using the Stewart equations, equation of motions you can call it. So that is A. Angular momentum is there, so we would be talking about the momentum and the displacement. So clearly displacement has nothing to do here. So if displacement is sitting here and acceleration is constant, some Stewart equations will be going on between these two variables. And then we would be finding something, and mass will be multiplied to create force and dynamics, and then we will enter into momentum. Okay, so let us think about okay, they're talking about the momentum. So momentum is related with kinetic energy. There is a formula, P square is equal to 2mk. And kinetic energy is connected with one particular Stewart equation, which is V square minus U square is equal to AS. Till now, I have not talked about the circular motion or rotational motion even once. Now, once I have the complete picture clear to me, I would be talking about circular motion. So let us find the final omega with which it is moving. Initially it is at rest, 2 alpha theta. So this displacement is theta. Displacement is given as 4 times the complete revolution. It means 4 times 2 pi. So it will be 8 pi. So theta can be substituted as 8 pi. Yes, because it is 4 times 2 pi, so it will be 8 pi. This is omega square. So it is 16 alpha pi, which is omega square. Now I want to find the kinetic energy. Now in this case, if we were talking about the translational kinetic energy and translational momentum, but now I want to talk about rotational kinetic energy. So rotational kinetic energy is given as half I omega square. So I just multiply half I here to make it kinetic energy. Similarly, the same will be multiplied on the other side also, because it is the principle of algebra. This and this gets cancelled out. It will become 8. So this is coming out to be 8 alpha pi into I. This is the kinetic energy. But this kinetic energy can be written as P square by 2m, which in the terms of rotational variables, P can be written as L and m can be written as I. So I would be just substituting it here like this, and I solve it. So L square, this 2 goes here, 16 alpha pi I square. Now you take the square root on both sides, so L will be equal to 4 alpha pi, sorry, alpha pi will be under the square root, 4 I alpha pi square root. So this should be the correct answer. L is equal to 4I root of pi alpha. So this is how we do this. All the best. Bye. Okay, dear students, another question from moment of inertia. Very good. So two small spheres, each of mass 10 kg, are 8 meters apart and connected by a rod of negligible mass. So you have to consider this. Because in these kind of questions, like when you are talking about the moment of inertia, the masses become very important. So if the rod was having the mass, the moment of inertia for the rod has to be either like remembered by you, or it should be given by in your formula sheet or something, like it will be given in your question something. So be very careful about what kind of masses are given in your moment of inertia. So there are only two masses we worry about. This is 10 kg and this is also 10 kg here. Okay, fine, no problem. This system rotates about an axis halfway along the road and at the right angle to it. So clearly the axis is somewhat like this, and these two, they are rotating like this, easily like this. Very good. What is the moment of inertia of the system? Very good. It's a simple and straightforward question. Listen to me. So in the moment of inertia, usually there are two different type of systems. One is called the discrete system, and another is called the continuous system. So continuous system is like the rod in which you have a continuous distribution of mass, like all through the volume, and you can talk about the spheres, you can talk about cubes and cuboid, those 3D diagrams, they are called the continuous system. Discrete system is when you are having this kind of a problem here, and the mass is supposed to be concentrated at the center here, like this here at the center. You can just assume that the mass 10 kg is concentrated at the center of mass. So such a kind of system is called discrete system, and you do not usually use the calculus for this. Like you can use the simple algebra here. So first of all, the moment of inertia of this will be mr square. You have to remember this formula. So I1 is given as mr square, and I2 will be separately found, like you can say M2R2, M1R1, like that. Although M1 and M2 are same here, R1 and R2 is also having the same value, that is 4 meters. But anyways, so this will be the momentum. Let me find it. The moment of inertia. So 10 into the radius is 4, and be careful about the units. 10 kg is SI, meter is SI unit, so no problem. So it will be 4 into 4 is 16, so it will be 160 kg meter square. That is the unit of moment of inertia. You can derive it from this kg meter square, yeah. And 160 will be for the other ball, kg meter square. So in such a kind of a case, when you have the same axis and both of the masses are attached to the same system, the total moment of inertia is just the algebraic sum, because moment of inertia is a scalar quantity. You do not worry about the vector additions and all. So you just need to add them. So you add it, it becomes 320. So your answer for this question will be 320 kg meter square. This is how we do this question. This is a very important question, I would say. Why? Because number one, it is simple, but it is highly basic. It is the foundational question which can be asked in the topic of moment of inertia. That is why this question is very important. Okay, dear students, thanks for watching this. This is Professor Varun. All the best. Bye. Okay, a very tricky question coming our way. Observer X sees a spacecraft moving in the positive direction with the speed of 0.5 c. Observer Y sees the same spacecraft moving in the negative X direction at the speed of 0.5 c. What is the speed of Y with respect to X? My God, it's a very tricky question, I would say. But let's see how to do this, how to comprehend this question. Now listen to me very carefully. Couple of things that usually they are not given in the book and all. So this is how I would be attempting it. This is how I would be doing it. Listen to me. So there is this rocket here, which I'm just calling it as R, and there is this observer, let's say X, and there is this observer which is Y. Like Y is also moving with certain velocity, and might be that Y is moving at a very fast speed, and that is why R is going, like the distance is increasing, although R is also moving towards right, but the distance is increasing between the two because Y is moving at a very fast speed. So there is a possibility that Y will feel that the rocket R is actually going away from me in the other direction. So that becomes the negative velocity. X might also be moving in certain velocity. We don't even know where is X moving, where is Y moving. We don't have any clue. This is how we do this question. So this is observer X sees the spacecraft moving with this speed. So speed of rocket with respect to X, and this is in vector sense, that is given as positive 0.5 c. Now be very careful here. Listen to this. Vrx, how are you going to write it? We can also write it as the velocity of the rocket minus the velocity of X, because you are taking the relative motion here from completely from Newtonian point of view, like Vr minus Vx. That is completely from Newtonian point of view. I would say VAB is the velocity of A with respect to B. That's it. This is how we write it. So velocity of R with respect to X is written as this, and this is given as the positive value. And what about the other, like the velocity of R with respect to X? So this can be written as velocity of R minus velocity of Y, sorry, not X. So velocity of R minus velocity of X, and that is given in negative. That is negative 0.5 c. Now what is going to happen? Now you want to find the speed of Y with respect to X. It means that you want to find speed of Y with respect to X. So you are looking forward to this arithmetic expression, and you are having two equations in front of you. How can you create the equation Vy minus Vx from this equation? See, Vy is here and Vx is here. Clearly this has to be made positive and this would be made negative, and then we can add these two things and things can be made easier. So I can multiply a negative to this equation and then we can add it. So how can I write? I'm multiplying negative sign here, okay? Vr minus plus Vy. This is coming out to be 0.5 c. Now I just add it. So Vr and Vr will get cancelled out when I add these two equations algebraically. It's complete solving for the simultaneous equations kind of thing. So it is Vy minus Vx. So Vy minus Vx becomes this plus this. So it is 0.5 c plus 0.5 c. Now up to this we have done. Now listen to me very carefully. This is how Newton would have solved this problem. If you were literally not talking about rocket, or you were like the theory of Einstein's theory of relativity was not valid, let's say, this will be the answer. Now this answer is coming out to be equal to c. Of course this is wrong because nobody can move at the speed of light. So there is the tricky part now. So whenever you have this kind of a combination, just to make it relative, like to the theory of relativity kind of thing, what we do, we create another formula for ourselves. So V Yx is equal to, like for example here we are adding these two velocities. Let's say V1 plus V2. We would be dividing it by 1 plus. It is plus in the numerator, so we would be having plus in the denominator, with V1 into V2 divided by c square. This is the expression that you have to be writing here, and once we do this, at that time they can cancel each other out, whatever, and so you would be getting the correct answer. Okay, so let us now substitute our values here and try to find what is the correct answer. So I'm getting rid of some of the values here. So if you want to note these things or want to see, watch it again, you can just go back. So let me substitute these values. This, like, you just have to remember it, like the formula for this is given in the data booklet, but that is given in the negative sense. Like you are having negative in the numerator and the negative in the denominator. You can go to page number 7 in your data booklet and you can find that formula there. So I'm writing it for the positive. This context sensitivity has to be learned. Now this will be 0.5 c plus 0.5 c divided by 1 plus 0.5 c multiplied by 0.5 c divided by c square. C and c and c, everything is getting cancelled out. So in the numerator you have c, half c plus half c is equal to c, and in the denominator you have this, so it becomes c divided by 1.25. so you can use the calculator, although we know that 1 divided by 1.25 is clearly 8, so it is 0.8, sorry. So it will be 0.8 into c. B will be the correct answer for this question. This is how we do it. Okay, students, listen to me. Number one, this question is from theory of relativity, so clearly this question is not easy, and of course the surprise was already expected that something big is coming our way when you are talking about theory of relativity, and that even in your IB final examinations, of course it was going to surprise many people. So in this question we are talking about the velocities. What is my method? My method is you just keep on moving according to the Newtonian physics until it starts becoming crazy. Okay, so first of all we try to analyze the question statement, what is written here, until you are able to get to this. Now once you get to this thing, that yeah, now I know like what is the velocity of y with respect to x. Now you know that velocity of y with respect to x is this. But of course it is wrong, because it cannot be equal to c. That is clearly wrong. I have already written here that is wrong. At this point we will stop Newton and we start thinking Einstein. So now what we do from this, so my principle is like if we are adding these two in the numerator, we are creating this expression in the denominator. So this positive and this positive go to the denominator here, and it is 1 plus v1 v2 divided by c squared. This is how we do it, and you just plug in this value there and you would be getting the correct answer. It is 0.8 c. This is how we do it. Dear students, the theory of relativity is an exclusively different topic which you might be finding difficult to understand, because it's not easy if you're learning it by yourself, or if you're learning from your book or something. You would be needing the support of a teacher who can teach you this thing. So I have uploaded all the lectures for theory of relativity on the YouTube channel already. You just need to become the member on YouTube channel with a very small amount, that is $5. Like that is nothing. $5 for the complete theory of relativity. And along with that you would be getting A2, A3, A4, A5, like all the topics are given. You would be able to watch all of them. So if you are facing the problem in theory of relativity, don't miss it. The link will be given after the video here. Just go to that, try to become the member here if that is available in your country, and watch all the videos. All the best, dear students. This is Professor Varun. Thanks for watching. All the best. Bye. Okay, dear student, let's see what is there in this question. A block of ice of mass capital M is at its melting point. Okay, so the ice is already at 0 degrees. So this is 0 degree ice, and the mass of the ice is given as capital M. The small mass m of water at the temperature T degrees centigrade is placed on the top surface of ice and remains there. The specific latent heat of ice is given as L, and the specific heat of water is given as C. What mass of ice melts? It's a very good question, but it is written in a very tedious manner, isn't it? So this question is from the topic B3, I think, which is like calorimetry, in which we are equating the heat gained by some substance which is equal to the heat lost by the other substance. Let us assume that it is m dash mass of the ice which is melted. So what is the heat required to melt m dash of the ice? So that will be m dash into L, because it is already maintained at 0 degree ice. So we have to convert it into 0 degree water. We're not increasing the temperature. We are talking about latent heat. So as I have always taught in my lectures and in my lecture series also, there are two types of heat. One is latent heat and another is sensible heat. So actually what this question is saying, that we are only concerned with latent heat. We are not concerned with the sensible heating for the ice here. So ice is literally having m dash L. This is the heat which ice absorbs, and m dash is the mass which melts. But who is giving that heat out? So the heat which is lost is this. So it will be mc delta T. So it will keep on giving heat to the ice until the temperature of this water, which is at T degrees centigrade, becomes 0 degrees centigrade. Once it becomes 0 degree water, heat transfusion will stop. So 0 degree water and 0 degree ice, they are not going to exchange heats with each other. That is not going to happen. So 0 degree water, 0 degree ice is going to maintain the equilibrium. So after this, the water at T degree will be converted into water at 0 degree, and this is ice. This ice is now melting. So ice is also melting from 0 degree ice to 0 degree water. So these two things should be equal to each other. So m dash L is equal to mct, because it is T minus 0, and m dash value will be given by mct divided by L, So A will be the correct answer, as we can clearly see on the screen. So the option is mct by L. So A is the perfect answer. This is how we do this question. Okay, dear students, so this is Professor Varun. All the best. Bye. Okay, dear student, let's go to the next question and see what is there. What is a primary cause of enhanced greenhouse effect? So it seems to be quite easy question, by the way. So the four options are melting of ice at Earth's poles, increases in volcanic activity, deforestation of rainforest, and burning of fossil fuels. Completely theoretical question. Now, in IB, there are two different type of greenhouse effects that we study in our topic. I think probably B2. So what we study in this is that there is one greenhouse effect which is created by the earth and which is good for us, which creates warmth for us on the planet, and that is why we are able to live on this planet. So that is good greenhouse effect. But then there is another greenhouse effect which is enhanced greenhouse effect, which is taken to be harmful. Of course, it is because of extra quantity of the carbon dioxide gas and the water vapors in the environment, and that is capturing the heat. So you all know the mechanism of greenhouse effect, isn't it? So we are basically addressing the enhanced greenhouse effect. Now, what is the reason for it? Melting of ice at the Earth's pole. Now, this is not the reason, this is not the cause. This is actually the manifestation of the enhanced greenhouse effect. Now, increases in volcanic activity, there is no major increase in volcanic activity reported ever. So we cannot say that B is correct. So B is also wrong. Deforestation of rainforest. Well, it might be taken as a reason because it enhances the enhanced greenhouse effect. It does play a role. The deforestation does play a role. But again, it is not the primary cause. The primary cause is burning of fossil fuels, and that is absolutely correct. Burning of fossil fuel means that you're burning coal in the thermal power plants and you're using petrol and diesel in our vehicles and all. So that vehicular pollution, the industrial pollution, everything is creating more carbon dioxide and more other gases, nitrogen oxide, which is highly responsible for creating enhanced greenhouse effect. So D is the correct option, the correct answer. C will not be the, it is also correct, but it is not primary reason. So we can say that D is a better option. That is why we will go for D. So for this question, D will be the correct answer. Thanks for watching. This is Professor Varun. All the best. Bye. Okay, dear students, so let's see what is there in this question. An ideal gas is held in a cylinder by a piston. The piston compresses the gas rapidly. The average speed of the gas molecules increases because the gas molecules. So what happens in this process is gas molecules are getting heated up. And more is the temperature, more becomes the average kinetic energy of the molecules. And so we can clearly say that the average speed of the gas molecule will increase. So actually the temperature of the gas is increasing. Okay, so before even moving into the options here, let me explain this process a bit more. See, in this question, they have not written whether this is an adiabatic process or whether it is what. Let me explain you that. It's complete, like it's a bit details we have to go here, but it is very important. This wall is not shown as the adiabatic wall, by the way. The compression is taking place and work is done on the system by the external agency because compression is taking place. And of course, there is a chance that it could be isothermal process or it could be an adiabatic process also. Let me explain. It could be isothermal if the temperature is supposed to be remaining constant. Now the walls are not adiabatic wall. Adiabatic wall is shown as thick walls like this. This is the adiabatic wall, but they are not showing this container with the adiabatic wall. So these are not adiabatic wall. But there is something written in the question. The piston compresses the gas rapidly. So when this word is written like rapidly, it means that the process will be treated as adiabatic process. Why so? Because the process is happening rapidly means that the gas in the container, it is heating up, but it is not having that much of the time so that it might be able to transfer heat to the surrounding. So the transfer of the heat is actually not happening because the process is rapid, not because the walls are adiabatic, but because the process is rapid. So be very careful about it. Because the process is rapid, we are going to treat this as adiabatic process. Now, what happens in adiabatic process? The delta Q is taken to be 0. And let me write the first law of thermodynamics and explain a bit more. Delta Q is equal to delta U plus delta W. Now you see, delta Q is 0, delta U and delta W. So the change in internal energy will be the negative of the work done. Work done is P delta V, we all know. So that is negative of work done. Now the work done is on the system. That is why work done is negative. It means overall this expression will give you a positive value, which means that there is going to be an increase in internal energy. So change in internal energy is positive, means that the final internal energy is more than the initial internal energy. And internal energy is only and only depending on temperature. We have done every of this thing in the topic B3 and B4 taken together, if I say. So the internal energy is increasing here, which is Cp delta T, Cv. Okay, don't be concerned with that. So internal energy is increasing. So the temperature is increasing. So this is the whole process. Now we are moving into the options. Have a smaller volume available in which they can move. That doesn't make any sense. Receives thermal energy transferred from outside. No. Why? Because it will be behaving as adiabatic process because the process is rapid. So that is not going to happen. Receive energy from piston as they collide with it. I don't believe so. And make more collisions every second with each other. No. Absolutely C will be the correct answer. Now listen to me. Receive energy from the piston as they collide with it. Might be that they're referring to the work done by the piston. So when the piston is moving here, work is done by the system, by the piston on the system. So work is done on the system. We can say that yes, the energy is received from the piston as they collide with it more often now. So indirectly, we can say that the work done by the piston on the system is converted into internal energy, and that is why the internal energy is increasing. This is the complete scenario of this question. I have tried to give you the answer for this, incorporating all the thermodynamic principle, the B4 principles, which is now in your syllabus. Earlier it was not, but now that has been added. So I have incorporated all of that. So the answer for the question number 12 will be C. This is Professor Varun. Thanks for watching the video. Keep watching other questions. Okay, dear student, let's see what is there in this question. Which pressure volume diagram represents the Carnot cycle? So that's quite simple and straightforward question coming directly from the topic B4. And you can clearly see out of this that I believe like C will be the correct answer, because let me explain you. Because let's say it's starting from this point. You can take any point as starting point, by the way. So two processes will be isothermal and two will be adiabatic. So this process is having a lesser slope and this is having more slope. So this is the adiabatic and this is isothermal. Similarly, this is isothermal and this is, do you see, like this is not a straight line, it is a curved line. The diagram is not that proper, by the way. So this will be taken as the adiabatic process. So clearly C will be the correct answer. Although the graph of this, if I redraw, the graph can be drawn like this. Just to make it a bit more clear, I can draw it like this. So this is exactly the same thing. And so C will be the correct answer in this question. By the way, there are other options that they have given, and I would like to talk a bit about it. See, I tell you, thermodynamics is a very big topic. When you go into your university physics, or you go for your physics in your as a subject in your university, you would be finding thermodynamics will expand itself into a very, very big subject. There are many other cycles, not only Carnot cycle, like the example shown here. This is the example of a diesel cycle. And then there are other cycles. They're named like Otto cycle. Then there is another cycle named Brayton cycle. There are so many cycles. Then there is another cycle, Lenoir cycle. Yes, there's so many cycles there. So once you go into your university, if you opt for physics, There you will be finding so many other cycles. I'm just giving you this piece of information to make physics even more interesting for you, nothing more. So this is the Carnot cycle, which is quite simple and straightforward, which is consisting of 2 adiabatic and 2 isothermal. This is diesel cycle, for just for the sake of example. This is isobaric, then it is adiabatic, and then it is isovolumetric, and then again adiabatic. If you're having this kind of a process, that is called the diesel cycle, by the way. For this question, the answer will be C, so there is no confusion at all. This is Professor Varun. Thanks for watching the video. All the best. Bye. Keep watching other videos. Okay, dear student, let's see what is there in this question. 3 combinations of resistors are shown. The resistors are identical. What is the total resistance of each combination of resistors in order of increasing resistance? Okay, dear students, I have seen so many these kind of questions, I tell you. And the bad news for you people is there is no shortcut for such kind of questions. So the fastest way in which you can do this question is just do it. Don't think about anything and just start doing it. That is the fastest method of doing this question. Let me show you how you do it. So these all are identical. This is R, this is R, this is R, and this is also R. So we know when two resistances, equal resistances, they are placed in parallel with each other, the equivalent of this becomes R by 2. So the total resistance here is R plus R plus R by 2. So 1 plus 1 plus half, 2.5. So you can say it is 2.5 R. Clear? You have to be as fast, and it is really that easy, and you can become fast. 1 2 3. So overall resistance here will be R by 3, and this resistance will be R. So the total resistance here will be R plus R by 3. Take the LCM. 3R divided by 3. We have taken the LCM there. 3R plus R becomes 4R by 3. You can do your arithmetic by yourself. This is how I do it. If you understand, you can copy my method. This is 4 by 3R. 4 by 3R I know is 1.33R. Why? Because the refractive index of water is 4 by 3. That we do in the Snell's law, the topic C3, isn't it? 4 by 3, the value is 1.33. That is how I remember it. So 1 by 1.33 into R. What about this thing? My God, you have to do all things now. You have to do the calculation by yourself. This is R and R. They are in series. This becomes 2R. 2R and R. I have given you one more formula in my theory classes, or if you are the member on YouTube channel, you can refer to those videos, how to find the parallel resistance. I've given you all the shortcuts. There is one shortcut, which is R1 R2 divided by R1 plus R2. I am going to apply this method because this is again the fastest method. This is R, this is 2R. You multiply. R into 2R is 2R square. R plus R, 3R plus R plus 2R is 3R. So it becomes 2R by 3. For this combination, it is 2R by 3. Now this is again in series. So 2R by 3 plus R will be your final resistance, 2R by 3. How to take the LCM? You just multiply here 3 and 3. So the LCM is 3. 2R plus 3R becomes 5R. So your answer is 5R by 3. Now you can just divide it. You have the calculator. You can do it on your calculator. I'm just doing it manually. So it will be 1 and 26, 6. So it will be 1.66 R. Now we can compare, and we have to arrange all of them in increasing order of resistance. What is the minimum one? So minimum one is Q, 1.33, then 1.66 is R, and then P, which is 2.5 R, is the maximum of them. So it will be QRP. That will be our final answer. We will see it from the options. This is how we do it. Mind it, dear students, if you ever get this kind of a question, there is no shortcut. This is the shortcut. This is how you do it. If you have the identical resistances placed in parallel, do not calculate it. It will be R by 2. You just divide it by number of resistances. 1, 2, 3. It is R by 3. If there will be 5 such resistances in parallel, it will be R by 5. You can watch all the videos on the YouTube channel if you become the member there, and you can learn these tricks. Now, what is the answer? QRP. Well, there you are. D is the correct answer for this question. This is Professor Varun. Thanks for watching. All the best. Bye. Okay, dear student, let's see what is there in this question. A continuous belt of width 0.6 meter travels at a constant speed of 2.5 meter per second. The belt has a uniform distribution of charge, which is 5 milli-coulomb per meter square on its surface. So be very careful about the unit. So this is 5 milli coulomb per meter square. So if you take a certain area here like this, and let's say this area is 1 meter square, so the charge on that 1 meter square area of that belt, that charge will be 5 millicoulomb. Okay, very good. As the belt passes a point, all the charge is removed and is carried as a current in a wire. So this is passing over this area here like this, and all the charge is moving into the wire, which is converting itself into current, and you have to find the current. Very good. What is the current in the wire? Okay, so this is one such critical thinking question. I would say it's a very good question. Kudos to IB for creating this. And if I was you in your examination hall, even I would be shocked to see this question in the first place. And my method in these kind of question is, because these are very critical questions, they do not have a set method like this is how you do it. There is no set method. So in these kind of questions, I have a tool that helps me a lot. Now, what is that tool? That tool is units. I don't know what to do in this question. I will concentrate on the units. That might be helping me out, isn't it? Let us see. So the answer that you want is in current, which is in amperes. Amperes can be broken down into coulomb per second. You have to do something with this data that gives you the unit of coulomb per second. That's a trick that we usually use. Later I will try to explain the question, like what is actually happening there. So this is coulomb per meter square. Let me start from this. This is coulomb per meter square. It means I have to get rid of meter square. So there must be meter square in numerator, and I have to provide second in the denominator. It means that I have to multiply this thing with meter square per second. So somehow I have to create this unit, which is meter square per second. Now concentrating here, I already have meter per second. If I am going to multiply it with meter, it will give me meter square per second. Okay, it means I multiply these two, 0.6 and 2.5, I get meter square per second, and then I multiply with 5 milli. It means I have to multiply all the three digits here, all the three values, numeric values, to get the right answer, because that is the way in which I'm getting the correct unit, which is coulomb per second, isn't it? So let us first try to find the answer. So according to this explanation, the answer will be 5 into 0.6 into 2.5. I am not talking about the milli. Why? Because answer is in milli. So I am not using the milli. I'm just multiplying 5, 0.6 and 2.5. The answer that I get is 7.5. So the answer for me is coming out to be 7.5 milliampere, which is exactly in their options. So I think B will be the correct answer for us. This is how we do it. But what is the explanation? What is now the rationale behind it? Let us now understand that. What is actually happening when we are multiplying this with this? What do we get? This and this is coming out to be like 0.6 multiplied by 2.5. The unit is meter square per second. It means it is the area here which is passing over a certain section in 1 second. We're talking about that area which is moving in 1 second. So we talk about the area that crosses over this surface in 1 second. And this area is having certain amount of charge that you get when you multiply with this. So you find what is the total charge which is placed on that area which is crossing over this section in 1 second. The total charge there is going to be converted into current. And when we are multiplying, this second is already there in the denominator. So when you multiply it, you find the area which is passing over in 1 second. You further multiply it with the charge per unit area. What you find is the total charge moving in that section per second. Hence, the answer will be B. Okay, dear student, let's see what is there in this question. A cube of side 1 centimeter has a resistance between the opposite sides as 50 ohms. So this is the cube here, and you can just imagine passing the current in the two opposite sides here, and the resistance is given as 50 ohm here. The material is reshaped into a block of length 4 centimeter and the constant cross section area. What is the resistance of the block between its square ends? So what is the resistance between of the block between its square ends? So what is the resistance here? So this resistance, like we are going to use the formula this, but the resistivity is not given. So of course we would be finding all the unknown variables from our first case, in which you're passing current from the cube. So the cube is there. So let me create this equation first of all. And I will not be converting units from centimeter into meter, but I should be, but because every unit is in centimeters and there is no addition and subtraction in the formula, it is only multiplication and division, it hardly matters, because even the multiplicative factors or the conversion factors, they will be getting cancelled out. So doesn't matter if we are using centimeters as the unit. So the resistance here is 50 ohms, is equal to resistivity, and the length will be taken as 1 centimeter, and the cross-sectional area will be 1 into 1, and even that will be 1. And I'm not converting it into meters. Of course it will be giving you a different value, but we can still, in the terms of the same units, we can use rho as 50, and we are going to substitute it here. Now for this case I am interested in this, like rho will be substituted as 50, length will be 4 centimeters, because we want to go like the current is passing from one square cross section to the another cross section. But the problem is this area is not given to us. This is unknown. So we have to find the area, and then we substitute that value here, and the rho value will be 50. You can find the new resistance. But how to find the value of A? Now the question, like read the question again. The material is reshaped into a block of length 4 centimeter. It is reshaped. It means that the volume of the material will be kept constant, because the density remains the same, the mass remains the same. So the volume will also be coming out to be the same. So the volume in the first case, because it is a cube, it will be A cube, like the length, the cube of that. So it will be 1 centimeter cube. 1 into 1 into 1. And what about the volume of the second rod here? Because this is a cuboid and it is having a constant cross-section area, but the length is not the same. This breadth is different, height is different, but we don't care. We just take it as A. The volume here can be written as A into H, isn't it? The cross-sectional area and the length. So it will be A into L. A is unknown and L is written as 4 centimeter. And both of these volumes are equal. It means 4A is equal to 1, which means that the cross-sectional area can be taken as 1 by 4 centimeter square. The units will always be in centimeters now, because we have not converted that. So the area here is 1 by 4. I just substitute value here, 50 into 4, and this is 1 by 4. So this 4 will go into numerator. It will be 50 into 4 into 4. So that will give you a value of 5 4s are 20, 200. 200 into 4 is 800 ohm. So the answer will be C in this case, 800 ohm. So you can clearly see that this cube was having a very small resistance, because the cross-section area was much bigger, and it was 4 times clearly, and the length was just 1 centimeters, and the resistance was 50 ohm. But in the second case, the length has become 4 times and the cross-sectional area has reduced by 4 times. So the resistance has become quite more. So the answer will be 800 ohm, and that is the answer. The answer is C, and according to the mark scheme, yes, the answer is C. Okay, dear students, this is Professor Varun. Thanks for watching the video. All the best. Bye. Okay, dear student, let's see what is there in this question. A mass spring system oscillates with time period T1. Another identical spring is connected in parallel with the first spring. The mass is unchanged. The mass is unchanged, but there are now 2 springs which are attached in parallel. The time period of the oscillation for the two spring system is T2. What is the ratio of T2 divided by T1? Okay, let us see how to do this question. So I believe the formula for the time period in the case of pendulum is given in your data booklet already. Yes, that the formula is given there. So the time period T1 will be written as 2 pi root of m by k. And when you are having the same identical spring here, which is connected in parallel to with it, so in parallels, how do we do? Like we find the k equivalent, and we know it that in when two springs they are in parallel, they are just added with each other. So the total equivalence is k1 plus k2, which in this case will be 2k. So now these two springs, they are actually, you can say that the system is equivalent of having one spring and having the same mass m, but only that now the spring is 2k. This is what you mean by equivalent spring. In IB books and others, they use the term total K, but I don't call it total K. I call it equivalent, which actually means that if these two springs are there, and instead of that, we want to have only one spring, what will be the equivalent K value for that single spring? So that single spring will be 2K. So here you can say that the time 2, it will be 2 pi root of m by 2k. So there is only root of 2 in the denominator, which is the extra term here. And you want to find the ratio T2 by T1. Be very careful whether it is T1 by T2 or T2 by K1. So we want to find T2 divided by T1. So T2 will be in the numerator. So root 2 will go into the denominator. So every other thing will get cancelled out. And so your answer will be 1 by root 2. I am skipping the arithmetic part here. You can just do it, or we can even write it like that, 2 pi root of m by k. You can do it in this way. T1 will be substituted here. It will be T1 divided by root 2. So T2 by T1 is 1 by root 2. So this will be our answer. Let us see what is the answer in the option. So my answer is 1 by root 2. Clearly, B will be the correct answer for this question. So this is question number 17. Yes, and the mark scheme is also saying that the answer is B for this question. This is how we do it. All the best. Bye. Okay, dear student, let's see what is there in this question. A wave is traveling through a medium. The variation with time t of the displacement d of a particle in the medium is shown. So my dear students, first of all, I would like to clarify that whenever we are doing like these kind of questions and the graphs are given, we have to make sure that like it is time on the x-axis or whether it is x on the x-axis. Like for example, in this case, they are talking about one particle system first of all, and they're having time on the x-axis. So whenever you have a graph with time on the x-axis, you talking about the simple harmonic motion of one particle. If instead of the time t, you would be having x and the unit will be meter or centimeter, the same graph will be corresponding to multi-particle system, and we would be talking about a wave. So that will be talking about a wave. But now, because it is time on the x-axis and we're talking about one particle, we are literally talking about the simple harmonic motion of one particle. Clear? So one thing is very clear, although that is already given here that you're talking about one particle, but this is how you clarify yourself, like what are you going to do. Now, what is the frequency and what is the amplitude? It's a very straightforward question coming just from our books, isn't it? So this is the amplitude. So the amplitude will be 5. The unit is nanometer. So it is nanometer and the answer will be 5. Yes, so either the answer is A or the answer is B. Now you want to find the frequency but not the time. The time is 4 millisecond. Always verify the units and the multiplier there. So it is 4 millisecond. So 4 millisecond is time, but you want to have the frequency, so it will be 1 by time. So the frequency will be 1 by 4 milli, which means 1000 divided by 4. So it is 2500, so it will be 250. So B will be the correct answer in this question. So this question is quite straightforward, coming directly from the topic C1, simple harmonic motion. Absolutely correct. This is how we do this. The answer is B. Okay, dear students, all the best. Thanks for watching. Bye. All the lectures for the topic C1, by the way, are free to watch on the YouTube channel. There will be link given after the video. You can go there, watch all the videos for the topic C1. All the best. Bye. Okay, dear student, let's see what is there in this question. An object performs simple harmonic motion with the frequency f. The distance between the extreme positions at which the object is at rest is b. Okay, so the b is the total distance between the two extreme positions. What is the speed of the object when it is halfway between its equilibrium position O and its extreme position? Be very careful. They are not talking about this half position here of the total b. They're talking about this point and the half position here. Okay, so let's find this. So we would be applying our concept of the energies in the simple harmonic motion. So the first concept is that the total energy in the simple harmonic motion can be found by finding the maximum potential energy, and the maximum potential energy is half k extreme here, which will be taken as b by 2. So it will be b by 2 whole square. This is the maximum potential energy which is going to which will be which will be at the extreme position. So it will be half k b by 2 whole square. That is the maximum potential energy. And we are using another thing that the total energy anytime it will be equal to the sum of potential energy and kinetic energy. So at this point we will first find the potential energy at this point here. So the potential energy here, it will be half k x square. So the x here will be b by 4 in this case now. So it will be b by 4 whole square. That will be the potential energy. Total energy will be this. From this equation, we are going to find the kinetic energy. It will be quite problematic as per arithmetic is concerned. So you have to be very careful here. From this equation, we first find the kinetic energy. Then we find the velocity, half mv square. I think that will be the kinetic energy here. Yeah, this is all. So this minus this. So half k b square by 4 is taken common. And this goes to the other side. It will be 1 by 4. Because 2 is in the denominator, like that is extra. And 2 square is 4. So every other thing is taken common. So it will be 1 minus 1 by 4. That will be equal to kinetic energy, which is half mv square. Half and half gets cancelled out. This will be 3 by 4. So our equation will be kb square divided by 4 into 3 by 4 is equal to m into v square. Now the tricky part is that we do not have k in our final options, so we have to get rid of k. And we have to get rid of m also. But how can we do that? There is a formula, k is equal to m omega square. Be very careful, this formula is not given in data booklet, so you can note it in the data booklet. K is equal to m omega square. You have to remember it. So I'm just substituting this value here, m omega square b square 3 by 16 is equal to m v square. M and m gets cancelled out. And okay, too many things. Yeah, b square. Now omega can be written as 2 pi f whole square into 3 divided by 16. That will be equal to v square. This is where we will be getting the answer. So open the bracket. 3 b square 4 pi square f square 16. So this will give you 4 and take the square root of this, that will give you the value of V. So B pi f and 2 goes out of the bracket because everything is having a square there, and the square root 3. So it will be square root of 3 by 2 pi f b. D will be the correct answer for this question. Quite difficult, I would say. There is high chance of creating some clerical mistake here, so be very careful. And this is how we do it. There is another formula for the kinetic energy that is usually given in our data booklet. Let me verify if that is given there. uh, yeah, that is not given in the topic C, but that's very good because we are never going to use that formula. Yeah. So my advice to you is, whenever you have energies in the simple harmonic motion, this is the method that you have to employ. There is no direct formula for kinetic energy. Be very careful, people. The only formula for the kinetic energy that you can use is half mv square. Don't go for any other formula, whether it is given in the book or whether it is given by your teacher or whether it is given in the data booklet. Please do not use any other formula. Okay, dear students, this is how we do this question. Let us see the answer for this. The answer for me is D, question number 19. Yes, absolutely. The answer for this question is D. So this is how we do this question. Thanks for watching. All the best. Bye. Okay, dear student, let's go for this question. Light passes through two parallel layers as shown. The refractive indices for the light traveling between the air and the media are shown in the diagram as N1 and N2. So the refractive indices, they are given here. The angle is 50 degree. What is the theta? So you have to find this angle. Okay, no problem. It means that we have to just apply the Snell's law at this junction, which should be straightforward and quite simple. Let's see. So the Snell's law, when like I'm thinking about this junction here, and this will be taken as the angle of incidence, this will be taken as the angle of refraction. So this is how the Snell's law is written. N into sine I is equal to N2 into sine R. This is how I remember it. And there are other methods, there are other formations. They might be given in the data booklet in some other different way, but this is how I remember. Okay, let me check the data booklet once again. Yes, they are definitely using the ratio pattern, like N1 by N2 is equal to sine theta 2 by theta 1. But I believe this method is better when you, like, for remembering the Snell's law. N1 is the refractive index of this medium, I is the angle in this medium, N2 into sine R. So let us apply that. N1 is 5 by 3 and the angle is given as, no, the angle is not 50 degree. We have to find it. This is 50. So this angle will be 40 because these two angles will be complementary to each other, 90 degrees. So 90 minus 50 is 40. This and this is alternate interior angles. If you remember, this angle will become 40 degree. So it is sine 40 degree is equal to N2, which is 4 by 3 sine R. So you have to find the sine R from this calculation. Quite easy, I would say. 3 and 3 gets cancelled out. 5 by 4 sine 40 is equal to sine R. You can directly use your calculator now. So 5 by 4 multiply by sine 40. And please be careful that your calculator should always be in degrees, not in radian. So it is 0.8 now, and then you have to take the sine inverse. Yes, the answer for me is 53.46. 53.46 degree, and clearly the answer will be C. So this is how we do this question. This is question number 20, and we can even verify the answer. Yes, the answer is C. So this is how we do this question. Okay, students, thanks for watching this video. All the best. Bye. Okay, dear student, let's see what is there in this question. Light of wavelength lambda is incident on two parallel slits of width b that are separated by the distance d. The graph of the intensity against diffraction angle is shown. So on the x-axis, you have angle here, the unit is radian, and the pattern is in front of you. This is interference pattern modulated with diffraction. Okay, what are the values of lambda by d and lambda by b? Okay, it's a straightforward question here. Let's see how to do it. So first of all, we know that there are two formulas, one for interference and one for diffraction, which involve the sine theta angle here. So sine theta is equal to n lambda divided by d is the formula which is used for interference to find the angular position of the individual fringes, like the first maxima, second maxima, and you want to find the angle between that. So that is given by this. Similarly, in the case of diffraction, the formula is sine theta is equal to n lambda divided by b, where b is the width of the slit. How does the slits look, by the way? This is how they look. Yeah, so this thickness here is given as b, and this distance here is written as d. D is the distance between the two slits, and b is the width of the two slit. Even this slit is having b width. So these are the formulas in front of us, but the angles will be different. Like I can call it theta dash, and that is theta, because both of them are pertaining to different points. Let me show you in the diagram. This is called the central bright fringe for the interference, for which the intensity is maximum. Of course, it will be 4 times I naught. I can just write like that because there are only 2 slits out of my own knowledge, but it is not required in the question, so don't get confused. What is required in the question is this first maxima. Now you see, you want to find the value of lambda by d. It means n value has to be taken as 1. So when you're talking about interference, n will be taken as 1. So you would be talking about the first maxima, which is adjacent to the central maxima, which is of course this one that I have shaded. So in a very beautiful manner in the graph, it is already given as the exact point, and so there is no confusion here, like what is the value here. It will be 0.01 because 1 2 3 4 5, and this value is 0.05. So this value can be taken as 0.01, more or less. Okay, of course, like there is some difference coming here, but we can neglect it. So 0.01. So for the interference, I can say sine of 0.01 is equal to lambda by d. So your answer should be sine of 0.01. But we have done in limits in maths AAHL that if the theta is tending to 0 or it is having a very small value, then sine theta is approximately equal to theta. This is what I'm saying. Limit tending to 0, sine theta can be approximated as theta itself. So 0.01 can be taken as very small value. So lambda by d can be approximated as 0.01 itself. So that will be your answer in the case of interference. I'm not showing you the answers as of now because I have to erase each and everything. So let me first do it and then we will find the answer. So this is our first point, that lambda by d is equal to 0.1. But what about the diffraction now? Now for the diffraction, again, we are using this angle, like sine theta dash is equal to n lambda by b. Again, in the case of diffraction here, n value will be taken as 1. So this formula pertains to the first dark point because of diffraction. Now where is that first dark point? So the diffraction curve can be created somewhat like this. So I can say that it is getting a dip at 0.1. So that will be the point where there is the diffraction minima, which is superposing the interference maxima at that point. And that is why our net output at 0.1 is becoming 0, because in the diffraction case, diffraction is modulating the interference pattern, making it 0. So sine theta dash is equal to n lambda by b, n is taken as 1. So we have to see like what is the angle here. It is 0.1. So in a similar fashion, I can write as sine theta dash is equal to lambda by b, and this theta dash will be equal to 0.1, which can be approximated to 0.1. So for the diffraction, your answer will be 0.1, and for the interference, it will be 0.01. This is how we do this question. Let me find the option, which option is correct. Remember, for interference, the first option will be 0.01, and the second one will be 0.1. And yes, C is there. So C should be the correct answer for this question. Let us verify it from the mark scheme. This is the question number 21. And there is the mark scheme. Question number 21 is C. So this answer is absolutely correct. This is how we do this question. Okay, dear students, thanks for watching the video. And be connected. Keep on watching other videos. They're all coming our way now. All the best. Bye. Thanks for watching. Okay, dear students, let's see what is there in this question. A pipe of length L is closed at one end. What is the wavelength of the fifth harmonic standing wave in the pipe? Okay, the question is quite straightforward. And when there is a pipe which is closed from one and open from the other, the formula for the harmonic frequencies is n into v divided by 4L. The problem is that the formula is not given in the data booklet, okay? So they are completely silent about the topic C3, to topic C4. And so this formula is not there. So when the pipe is closed at one and open at another, the formula is this. When the pipe is open at both ends, or there is a string which is fixed at both ends, the formula in that case will be n into v divided by 2L. So that becomes the formula, but we don't care about that because the question does not ask for it. So Fn is equal to n into v by 4L. So what will be the frequency for the fifth harmonic? So F5 will be 5 times v divided by 4L, where L is the length of the pipe. Now the question is about the wavelength. So v is equal to f lambda. Lambda can be written as v divided by f. So it will be v divided by 5v into 4L, because it is in the denominator. So when there is a fraction which is in the denominator, you multiply with the reciprocal of that. So that is what we have done. So 4L goes to the numerator. V and V gets cancelled out. So you are getting the answer as 4L by 5. And the answer for this question is C. This is how we do it. It's quite simple, straightforward. The only problem is that the formula is not given in the data booklet. Okay, so you have to remember this formula. Keep this thing in your mind, otherwise and in this formula, n is always the odd number. You have to keep this also in mind. So n can be equal to 1, 3 and 5. 4 or 6 is not possible in these. Only odd harmonics are present in this. Okay, dear students, all the lectures for these these topics, they are already uploaded on the YouTube channel. You can just go and check them, become the member, watch everything and be perfect in these. Okay, dear students, all the best. Bye. Thanks for watching. Okay, dear students, let's see how to do this question. Light of wavelength 5.8 10 to the negative 7 meter is normally incident on a diffraction grating that has 400,000 lines in 1 meter. How many maxima can be observed with this diffraction grating? Point number one that I would like to make here for this question is, this is a very popular question with IB. And this is not the first time that I'm asking this question. This has been asked so many times over last 30-40 years, I would say. They have consistently asked the same question again and again, which clearly means that students are facing problem in these kind of questions repeatedly. Today, let us seize that. And you will not be finding problem later on in this kind of question. Let's see. So what we do, point number one that you have to remember is, in the case of diffraction grating, the name is diffraction, but the only formula that you use is interference formula. Sine theta is equal to n lambda by d, not b. If it was b, it will be diffraction formula. It is d, it's similar to interference formula. This is what we are going to use in this question. Now, sine theta value has to be lesser than or equal to 1, always, that we know from mathematical point of view, because sine theta is, it is always having values ranged between 1 and -1. So, you know it in maths, isn't it? So sine theta is less than or equal to 1. Now let us plug in the values and find the value of n. So n wavelength is 5.8 10 raised to the power negative 7, and D value, how are you going to find the value of D? It is not given directly, but they have given that there are 400,000 lines in 1 meter. So D value will be obviously 1 meter divided by the total number of slits, that is 400,000. That becomes the D, and the unit is still meters, so there is no multiplicative factor there. So we just plug in this value here. It will be 400,000 like this. This value has to be less than equal to 1. We want to comment on the value of n. So n, now this fraction, like we are just going to create a reciprocal there. So it will become 5.8 10 raised to power negative 7 into 4 into 10 raised to power 5 less than equal to 1. Yeah, like this. And we have to find the value here. So this value gets cancelled out, and you are still having 100 in the denominator. But what is 4 multiplied by 5.8? So 4 multiplied by 5.8 will be 23.2. So n value can be written as lesser than 100 divided by 23.2. So which gives you the value of 4.3. 4.3. It means n is an integer which is having value lesser than 4.3. It means that n value will be equal to 4. It cannot be anything else, no? N value is equal to 4. Now, another catch in this question is people will directly jump to the option and they will say, oh yeah, A, there is 4 written there, and you would be ticking it, and you will say that yeah, A is the correct answer. But beware, this is the another point where students are always making mistake. 4 is not the right answer. The question is about how many maximas can be observed with this diffraction grating. 4 is the maxima only on one side. What is happening? Like, do you remember the other question when there were so many lines there? So you would be getting those kind of, that kind of a pattern here. Like this is central maxima, then 1, 2, 3, 4. Like this. And then here, 1, 2, 3, and 4. So overall, 4 here, 4 here, 8 and 1 here, 9. So total 9 will be your answer. How many maximas can be observed? Because at this point there will be the first diffraction minima, and here it will be the first diffraction minima. So we are only concerned with this much of the area, and including the positive and the below one, there will be 4 up, 4 below, 8, and 1 will be the central maxima because it is counted as 0. So total there are 9 fringes which will be visible. So this will be your correct answer. And this is a repeat telecast question, so no worries, no wonder if the question comes back again. So be very careful about this question. Let us verify the answer for this question. Well, yeah, I know the answer is D, so no problem. We can take that. Okay, dear students, thanks for watching the video. All the best. Okay, dear student, let's see what is there in this question. A planet P has a diameter 1/3 that of Earth. The mass of Earth is 18 times that of P. The gravitational field strength at the surface of Earth is G. What is the gravitational field strength at the surface of the planet P? Okay, in this kind of question, there is a set pattern. You have to follow that pattern. This is a ratio question, which is very typical of IB, and they can create these kind of questions from every other topic. Okay, there is no limit. So the planet P has a diameter 1/3 that of the Earth. So by the diameter, you can even talk about the radius. We can say, so the radius of Earth is taken as R. So the radius of the planet P will be taken as R by 3. Instead of that, we can do one more thing. You can choose R as the radius of the planet P and 3R as the radius of Earth, because we can get rid of fractions. That will help you in calculation, and you can avoid your calculation mistakes. That is why. So the planet P has a diameter or the radius as R, because the radius is half of the diameter in both of the cases. So radius is, the radii will be in the same ratio. That is why. So this is radius R, and the radius of Earth can be taken as 3 times that. The mass of Earth is 18 times that of P. So P is assumed as M, and the mass of Earth can be taken as 18m. So it is highly recommended that when you do this kind of a question in your examination, try to write the things the way I have written. R, 3R, 18m, and M. The gravitational field strength is G. Okay, so let us first understand G. So G value is given as gm divided by r squared. The formula is given in the data booklet. So in the case of Earth, the mass of Earth is 18m and the radius of Earth is 3 times r square. This value will be taken as G. Whatever value comes out, this is G. So this is 18, this is 3 squared, that will become 9. So 9 2s are 18. So you are getting the answer as 2 gm divided by r square. Now let us talk about G dash, that is the planet. So what is the mass of the planet? The mass of planet is written as m and the radius is written as r. So it is gm by r square. Straightforward. This value is written as G dash. So you can just substitute it here, G dash. So this means G dash is equal to G by 2. So B will be the right answer. Now again, this is a typical question that IB asks again and again, repeated. So this question can always be in your examination. This is how we do it. But till now, it was always like the other planet was having 3 times bigger radius and it was having 3 times masses. But in this very case, it is exactly opposite. The Earth is bigger. It is having bigger mass and the radius is also bigger. And we are talking about a smaller planet. So this is, like, I can say that that is the only change with respect to the other questions. But they have asked these kind of questions so many times now. Okay, dear students, all the best. Thanks for watching. Bye. Okay, dear student, let's see this question. Which graph shows the variation of gravitation potential with the distance d from the surface of the Earth? It's a very, very important question again. Oh my God, this question paper is having so many important questions and which have been repeated so many times by IB time and again. And even then, I cannot say that questions are easy. They're very good questions, I would say. Now, what is happening in this question? See, these kind of questions like what is the variation of the gravitational potential V with respect to the distance from the center of the Earth, from the center of the sphere or something, they were earlier coming only from the topic D2 and they were always talking about a charged conductor. Like this is the charged conductor here and you have to draw the graph from the center to all of the distances and how is the potential varying and how is the force varying there. These were the questions that IB has been asking till today. And these kind of questions, they were always from D2. I believe probably this is the first time when they're asking for this graph from gravitation from the topic D1. That has never ever happened earlier. This is the first time. But yeah, similar questions on the spherical bodies have been asked so many times. And on it, I can give you one more piece of information. These topics, they are not properly covered in your books and they are not covered in your schools also. So sometimes there is that kind of a problem that student is not able to understand like what is happening here. So I have uploaded all the lectures for this conductor where I have drawn all the graphs for the Coulomb force and the electric potential, which can be positive as well as negative. All those lectures are already available on the YouTube channel, but they are in the playlist D2. So you have to become the member on the YouTube channel to watch those lectures. Okay. I will share the link for the playlist at the end, so you can even go there to watch them properly. But if we follow the same principle and the same rule, we can go for the topic D1. Now, all the lectures for the topic D1 are free to watch. They are all available on YouTube channel. Again, the link for the same will be given at the end of the video. You can go to the gravitational playlist and you can watch all the content. SL as well as HL is available. Now, coming to this question, the graph of potential, as I have written here, the graph of potential in the topic D2, we can make it like this. Now this is positive charge, so positive charge is always creating positive potential. So the graph comes somewhat like this, and the potential is constant inside the sphere. At the surface, it is maximum, and then it moves in a hyperbolic manner. So the formula for the potential, like, okay, I would be giving you the formulas for gravitation. The graph is similar to this. Now in this case I have chosen positive charge, so the graph is positive, but in the case of gravitation the graph is always negative. Why? Because potential is always negative. And why so? Because gravitation is only and only attractive nature. It is never repulsive. So whenever the forces are attractive, you have the negative force and the negative potential. So potential graph will always be negative. So C is wrong, D is also wrong, because these graphs are positive. Now, on watching these two graphs closely, you can clearly see that they are actually showing you approximately similar values, isn't it? Like even I have drawn the graph like this. If I would be drawing graph like this, it is very difficult to say whether it is this graph or whether it is this graph. Now, they have not shown this region here. Why are they not showing this region here? Because on the x-axis they have already written that the graph starts with R. So they have chosen this as the y-axis here, and they are not concerned with this area, so they have omitted this graph. So only other graph is available, and that even in the negative region, somewhat like this. But in this case and this case, they're very similar looking, but in this case the slope is bit more steep, and here it is not that steep. It is going like this, but this graph is bit more skewed. So if I overlap this graph here, if I draw the graph here, the graph is somewhat coming like this. So it is more steeper. Now we have to use a bit of our mathematics knowledge. The formula for the gravitation potential is negative Gm by R, and the formula for the gravitational force, which is also can be taken as negative Gm by R square, because it is attractive force. So when you draw these two graphs, R square, it makes a bit more skewed graph like this. And if you are concerned only with this kind of a graph, like only with this formula, like 1 by R, where there is no square in the denominator, the graph comes out to be like this. So this skewed graph will be for the force for R square variation, when F is directly proportional to 1 by R square, sorry, not F, V. Yeah, V. And when V is directly equal to 1 by R. So of course this is right and this is wrong, because V is directly proportional to R. So B becomes the wrong answer, A becomes the right answer. My dear students, I know this question is not easy. There are too many things here, too many things. And if you literally want to understand this question, you have to know too many concepts. Like you should be good with the topic D2, the potential and all, and why the positive charge is casting positive potential, and why the negative charge will be having negative potential. But in the case of gravitation, there is only negative, not positive always. So it is always negative. You should be good with this concept. Along with that, the formula should be visible to you. Yeah, that the potential is directly proportional to 1 by R, and the graph, this graph is a bit more skewed. Why? Because here the variation will be R square and here the variation is R. So actually the variation is with respect to R, not R square. Hence B is the wrong option and A is the correct option. Otherwise you will be really getting confused in this question, like because A graph and B graph, they look really simple, similar. So this is it. And if there is any other doubt that you have in this question, please mention that in comment section. There will be no surprise if I'm getting some questions in the comment section there. Okay, dear students, thanks for watching. I have tried my best to explain this thing. You can help yourself with the lectures for the gravitation, which are free to watch on YouTube channel. The playlist is shared here. And for D2, you have to become the member, and then you can watch the complete spherical body topic that I have already given there. All the cases are covered there. So you just have to become the member on the YouTube channel. Okay, dear students, all the best. Bye. Thanks for watching. Okay, dear student, let's see what is there in this question. The unit of mu naught into epsilon naught expressed in fundamental SI unit is, oh my God, now this is a cornerstone question, I would say. Now listen to this. There is a formula. Maxwell gave a theory And this theory came in 1862 about the electromagnetic waves. And he said that the speed of light can also be written as mu naught epsilon naught square root. The formula is not written in data booklet. So the students, those who are only concerned with data booklet, and I keep on telling you, remember this, remember that, and people say, the formula is not given in data booklet, so I will not be remembering it. This is a wake-up call for you people. This formula is not written in data booklet. So in your examination hall, there is nobody who is going to help you in this question. Nowhere, like you cannot be looking anywhere like what the hell is this? You don't know it. On it, the Maxwell's theory of electromagnetic wave is not that deeply covered in your syllabus. So I'm like 99% sure that students will be getting confused in this question. But there is a catch. In my lectures that I have uploaded on the YouTube channel, in the topic list of the topic A5, I have first discussed the Maxwell's theory. And I have given you this theory. I have given you this formula in my lectures. So the students, those who are already the member on the YouTube channel, you can go to the topic A5 and search for Maxwell's theory, and you will learn each and everything about this. Now, we are going to use this knowledge here. Now, c is the speed of light, which is meter per second. So this is meter per second, which is equal to 1, or what I can do is I can first separate mu naught epsilon naught. We can square these two things on the both sides. So it will become c square is equal to 1 by mu naught epsilon naught. And you want to find the expression for mu naught epsilon naught, that will be 1 divided by c square. Now I'm going to substitute the unit of speed into c. So that will become 1 divided by meter per second square, which means it will become second square divided by meter square, which means it will be A. So meter minus 2, second 2. Yes, so A will be the correct answer for this. So my dear students, from this question, I would like to tell you one thing. Like, one thing is pretty clear. IB can ask you these kind of questions, like which are way beyond our comprehension sometimes. Not always, like out of 40 questions, you could be finding 2 or 3 such questions which are really beyond you. Okay, so whenever I tell you something that you have to learn this thing in my other videos or somewhere, do not think that this and this is not in your syllabus, this and this is your syllabus. Please don't create any argument there. Just try to remember the formula that I'm telling you. This formula is already uploaded on the YouTube channel in my lecture series, because I thought that they might be asking you this, and literally May 2025, they have asked this question. Probably they have asked this question first time in the complete history in their examination. They have not yet asked this question, probably, I think. So this is how is it. Okay, dear students, all the best. Thanks for watching this video. Bye. Okay, dear student, let's see what is there in this question. 2 parallel conducting plates, they are separated by a distance of 5 centimeter. The variation of electric potential with the distance between the plate is shown. So the variation of the electric potential is given with respect to the distance. With respect to the distance. What is the magnitude of electric field strength? Okay, so let me get the data booklet and see if the formula is given there or not. I am on the page number 12 of your data booklet. And yeah. Okay, so the formula is given there, but not properly. E is equal to V by D is the formula given for SL students. And for HL student, E is equal to delta V by delta D is the formula which is given there with a negative sign. Yes, so the negative sign is also given there. So this formula is given in the higher level section. This is for the SL section, you can say. But what is the formula and the concept that we are going to use here? E is equal to negative of dV by dr. Now, you have done a bit of calculus in your maths AAHL, so you already know what I have written there. E is equal to negative dV by dr. I can say that the electric field intensity can be found by, or it is equal to, the negative of the slope of VR graph or VD graph. Okay, so this is the graph here, this is V here, and K is also written. Be very careful about the units and the multipliers. So this is SI unit and the multiplier is kilo. Here the unit is centimeter, so you got to convert it into meters. They have already played the game. IB always messes up with this thing. So be very careful. So the formula that we are going to use is this. So clearly you have to find the slope. So these formulas, yeah, this formula can be used here. Delta V by delta T, you can say that. So the slope of this will be the tangent theta. Tangent theta is 20 minus 0, y2 minus y1 divided by x2 minus x1, which is 5 minus 0. But let me think about the units now. So it will be 20k, and this is 5 centimeters, which has to be converted into meters by dividing it by 100. So this will be further divided by 100. So 100 will go into the numerator. So I can just write the same thing as this. So 1, 2, 3, 4, 5, 6. So it is 2 into 10 raised to power 6 divided by 5 is the tangent theta that you have. Now this is the slope, and we want to find the negative of the slope. Okay, so the slope here is already negative. The graph is going down. This is the negative slope already. This is negative slope already. So the answer will be negative 2 by 5. So you want to find the negative of the slope, which is negative. So negative and negative cancels it out. So it becomes positive. So electric field value will be 2 by 5 into 10 raised to power 6 Newton per Coulomb, which is the unit for this. And how can we write it? 20 divided by 5 into 10 raised to power 5. Forza. So it is 4 into 10 raised to power 5. D will be absolutely correct answer here. Couple of things here. So first of all, we must understand what formulas are given in the data booklet and what are not given in the data booklet. The formulas which are given in the data booklet, what are the formations of that, which might be usable or which might not be usable. For example, in this case, they have literally skipped the derivation part and they have created their own formula. By the way, if you would be using the HL formula, yes, you can achieve the results, but this becomes a bit more easy and understandable because it is negative of dV by dr, which is the slope of V and R curve. So if tomorrow there is not a linear variation, some other variation is given, you know that you have to find the slope of the tangent at that point. But anyways, so the slope is given as this. Now the slope is negative because the graph is going down. This slope is positive. This slope is negative. Okay, the students, those who get confused, for them. So this is negative. So the slope is already negative, and you got to have negative of the negative slope, which becomes positive, and that is why your E is directly given as this. Now I just found the options here by just doing a very small arithmetic calculation. This is how we do this question. Beware of these formulas. Okay, dear students, this is Professor Varun. Thanks for watching. All the best. Bye. Okay, dear student, let's see what is there. In this question, the charge is moving in a wire that is at right angles to the uniform magnetic field. That is usually the case. Like charge is flowing through the wire means that the wire is containing current. So current is passing through the wire and the wire is perpendicular to the magnetic field, which is usually the case with IB, isn't it? So we can just imagine there is this wire, the current is I, the magnetic field is into the page. So that is why like the magnetic field is at Z axis and the current is along the X axis. So they are 90 degrees. So our first condition is fulfilled. The length of the wire is 0.32. When the current in the wire increases by 5 amperes, the force acting on the wire increases by 4 millinewton. What is the strength of the magnetic field? So first of all, the formula that we are going to use here is F is equal to BIL sine theta as given in data booklet. Yes, I believe page number 12 probably. So BIL sine theta, theta is 90 degree. That can be written as B into I into L. Now, if I'm just calling it at F1 because this is the first case. Now in F2, second case, the magnetic field remains the same. Current increases by 5 and length also remains the same. So L and B can be multiplied. It will become BIL plus 5 times B into L. So this is the new force that is acting on the wire. and it is given that the force, which is this, is actually equal to F1 plus 4 milli, which can be written as F1 plus 4 divided by 1000 here. Now F1 is equal to BIL. I can just solve this equation. F1 and BIL will get cancelled out because the same value is getting added on both of the sides. So I am left with 5B into L, which is 0.32, is equal to 4 divided by 1000. You can simply find the value here. B is equal to 4 by 1000 into 0.32 divided by 5. This is the value that we should be getting. This is the correct value. Let me find the value on the calculator now. 4 divided by 1000. And yes, I'm getting the value as 2.5 milli Tesla. A is absolutely correct. This is how we do this question. Initially, I thought that calculation could be a bit more tedious here, but because we are able to cancel F1 with BIL directly here, so that is why we are saved. Otherwise, it will become such a hectic calculation. It will be a bit more longer video, I would say. Okay, so let us verify if the answer is A for question number 28 or not. So this is your mark scheme, and question number 28, yes, the answer is A, and this is how we do this question. Thanks for watching the video. This is Professor Varun. All the best. Bye. Okay, dear student, let us see what is there in this question. Negative charge carriers travel counterclockwise in a circular coil. Negative charge carrier means that they are talking about the electrons, and electrons are moving in a particular manner, like the counterclockwise. So this is clockwise, so the electrons are going in this way. So electrons are moving in this way, means current is in the opposite direction. So current is going in this way, isn't it? Yeah, this is the value of current, the direction of current, because current's direction is always opposite to the direction of electrons. In the circular coil that lies in the plane of the page, the coil is in a uniform magnetic field directed into the page. So it is written that the electron is going into counterclockwise. We found the direction of the current. Now we can even imagine that the positive charge is going in the opposite upward direction. We can imagine that. What is the magnetic effect on the coil? So for this question, first of all, you should be good with the magnetic laws in which you can find the direction of the forces. Now, students usually face problem with how to find the direction of the force and all. And that becomes the most important topic in the topic D2 for magnetism, because you do not have the formulas there. There is no mathematical part. You need not to find the magnetic field or something. You just need to find the directions. So that becomes utmost important for you. By the way, for the same topic, like how can you find the magnetic directions and all the right hand palm rules and others, I have already uploaded so many videos. So I am using the law which is called the right hand palm rule. So you can just write right hand palm rule Professor Varun on YouTube channel, and you will find this kind of a hand in the thumbnail. Okay, so you just find that video and try to learn it. There are 3 types of right hand palm rule that I use. I do not use Fleming's right hand rule or left hand rule because they usually tend to confuse students. This rule is far better than that. So if you're interested in learning more about it, you can go to that video and you can watch that video. That video is freely available for all of the students. Okay, so right hand palm rule, and this is about the force. So this will be the right hand palm rule type 2. By the way, this wording type 1, type 2, type 3 is my wording. So please do not write such wording in your examinations. In your examinations, you will still be calling it right hand palm rule. That's it. Rather than type 1, type 2, right hand palm rule. That's it. So how do we work here? Right hand palm rule for the forces. Your thumb will be pointing towards the direction of the positive charge, or you can say the direction of the current, and your fingers will be pointing towards the direction of the magnetic field, and your palm will give you the direction of the force which is acting on the wire at that point. So let's say we're talking about this point here, and the current is going in the upward direction, and the magnetic field is into the page. So I can just go like this. So the fingers are pointing into the page and thumb is pointing in the upward direction. Where is my palm looking? My palm is looking towards left hand side. It means that this wire is experiencing a force in this direction. Clear? But what about this point? Let's say, so the current will be moving in this direction here. So the magnetic field is into the page and the current is towards right hand side, and my palm is now directed to into the upward direction. It means that this value is going up. Similarly here, if you find the force will be outwards, here the force will be outwards. So whatever point that you apply this law, these are the directions of the forces that we are finding. What does it mean? It means that the magnetic force is trying to stretch the coil, and so thereby trying to increase the diameter of the coil. So what is the option here? The diameter of the coil will tend to increase, and that is absolutely correct. So C is the correct answer here. So my dear students, right hand palm rule type 2 has made it so easy for us to find this. So you can just like the palm is there, and this is the direction of the current which is changing. So you can just move it like this. You can move your hand like this throughout the coil, and you can see that the direction of the palm is changing all the time. And that is why the direction of the force is also varying. Hence, C will be the correct answer. Okay, so this video is for right hand palm rule is available on YouTube channel. You can search on it. By the way, the topic D2 is also completely uploaded on the YouTube channel. If you become the member, you can watch the complete lecture series for the topic D2. Okay, dear students, all the best. Thanks for watching the video. Bye. Okay, students, let's see what is there in this question. Who was the first scientist to show that electric charge is quantized? Yes, my dear students, this is again another piece of information which is not usually available anywhere. But again, you might call it that I am bragging about my lectures. But if you have seen the lecture series in the topic D2 and D3, when we literally talk about the Millikan's oil drop experiment, I have pointed out at that point that it was Millikan who first created the formula Q is equal to N into E. It was Millikan's oil drop experiment where he was actually trying to find the charge on the drop. And he used that thing, like now you already know what Millikan's oil drop experiment is, by the way. So this was, these are the two plates here. This is positive, this is negative. So he tried to vary the electric field across the plates in such a way that the oil drop, it starts levitating inside the space. So thereby the electric force QE and the weight, which is mg, they try to balance each other. The charge on the point on the drop is negative charge, so QE is equal to mg, and from there he tried to find the value of the charge in various cases. Later he found that whatever value that he is getting, it is always a multiple of the elementary charge, the charge on the electron. So it was Millikan who found this concept that Q is equal to N into E. The property is called quantization of charges. Q is equal to NE, and this is literally in your syllabus. IB has asked so many questions on quantization, so do not skip it. And this complete concept, even the quantization, has been dealt deeply in my lecture series, as well as the Millikan's oil drop experiment is also available in the lecture series, so you can refer to that. Okay, dear students, so for this question, of course, there is no doubt about it. The answer for question number 30 is B, that is Millikan. All the best. Bye. Okay, dear student, let's see what is there in this question. A coil of wire rotates at a constant angular speed omega in uniform magnetic field. The variation with time for the EMF of the coil is given. The angular speed is changed to this. What is the amplitude of the EMF and the time period? Very good. Again, this is a very important topic, very important formula that we are going to use. And also, this question is not the first time that IB is asking. It has been asked many times earlier. Sometimes the omega becomes half, sometimes the omega becomes double. In this case, omega is becoming 0.75 times, isn't it? So Essentially, it is the same question, and you might find similar questions on my YouTube channel. Already, you can just check the playlist and you can find so many questions based on the same concept. So, which clearly means this concept, it becomes immensely important for us. We cannot miss understanding this. Okay. Now, so there is this formula of the EMF, and that is given by NBA omega sine omega t. This is the formula for the EMF. And that can be derived very easily if you go for the derivation for the rotations of the coil and all. This is in the topic D4. Let me see if the formula is given there. Well, the formula is not present in the D4 or in the data booklet. So you have to note this formula. And how do you derive it? Like, all the lectures are there on YouTube channel. You can watch them, by the way. So the flux is B into A cos omega t, and then you differentiate it. So EMF is equal to d phi by dt, negative. So this comes out to be NBA omega sine omega t. And from there, we are getting this formula, by the way, in short. So omega is coming twice in this equation at two different locations. Now, this omega is related with the time period. So omega is equal to 2 pi by capital T. So if something happens to omega, you can just find what is going to happen to the time. So if omega is double, the time becomes half. If omega is half, the time becomes double. Now, in this case, the omega is multiplied by 3 by 4. So time is multiplied by 4 by 3. So first of all, the time period will be multiplied by 4 by 3. That will be the new time period. And that comes from this, that omega is equal to this. So if omega is changing, then the time period will also change. Simple ratios, you can just do the algorithm, the algebra. And so accordingly, you will find the value 4 by 3 t. Now, omega is coming at the second place also, which is exactly in the amplitude of the EMF. So the amplitude of the EMF is directly proportional to omega. Now omega is multiplied by 3 by 4, which means that the EMF is directly multiplied by 3 by 4. It means that your amplitude is also becoming 3 by 4 times. So amplitude will be 3 by 4 times the earlier one. Earlier it was 10, so you multiply 10 here. So overall it is kind of 7.5, 30, 15, yeah, 7.5 volt. And the time period is 4 by 3. The time period here, okay, now that is a twist. So we have to find the time period value. 1, 2, 3, 4, 5. So in 4 milliseconds, again, be very careful about the multiplier in the unit. 4 millisecond, 1, 2, 3, 4, 5, 5 oscillations. So one oscillation is having 4 by 5 millisecond time period. So it will be 4 by 3 into 4 by 5 milli. So we are going to find this value there. So one moment, please. Yes, I'm getting the value as 1 milli. So time period will be 1 millisecond approximately. And this value is 7.5. Let us see if there is any option that talks like this. 7.5 and 1.1. Absolutely correct. So D will be the right answer. And this is how we do it. So this formula has been asked time and again by IB. You can even write it in your notebooks there. E is equal to NBA omega sine omega t, where N is the number of coils, B is the magnetic field intensity, A is the area of the coil, and omega is the angular velocity with which the coil is rotating. So this is the formula we are going to use. This is very important topic. Okay, dear students, so all the best. This is Professor Varun. Thanks for joining. Okay, let us first verify the answer. After that, there will be a bye. And this is question number 31. And yes, the answer is D. And this is how we do it. Okay, then, all the best. Bye. Let's see what is there in this question. An ion X contains the following particles: 53 protons, 89 neutrons, and 54 electrons. What is the nuclear notation? Now this notation is known as nuclide. So you have to create the nuclide for this nucleus. So X, A, and Z. Z is the number of proton, like the proton number. So directly 53 will be coming here. There is no doubt about it. A is the mass number, which is the total of the number of proton and number of neutrons. And that is 53 plus 89. So 53 plus 89 comes out to be 142. And the electrons are 54, so that doesn't matter because we do not include electrons in the nuclide. By the way, we can even include that also. I will show you, like, because that will be an ion. But let me show you what is happening here. First of all, let us find the answer. Yes, so A is the correct answer and all other are wrong. So there is no doubt about it. But if let's say there is one electron more, you can even write -1 here. So that means that there is one electron which is added into the nuclide, which is not required, but it is having one more nuclide, one more electron. If let's say you have taken away a couple of electrons, like 2 electrons have gone by, so I will say like 53 protons, but 51 electrons. So there will be +2, overall +2 charge on the nucleus. So ions can be created this way, but we don't care because that is not available in the options. Hence, the answer for us will be A. This is how we do this. Okay, students, all the best. Thanks for watching the video. Okay, students, let's see what is there in this question. What is the variation with nuclear number of the density of the nuclei? Okay, time and again, they are asking the same question again, the density of nucleus. So there is a concept that the density of nucleus is constant. Okay, so the density of nucleus does not depend upon the nuclear number. Whether you talk about hydrogen, whether you talk about helium, or whether you talk about uranium, the nuclear density is always taken to be constant. So clearly C will be the answer. A, B, and D cannot be because nuclear density never changes. But how can you say that? Let me give you a bit of explanation on it. So there is a formula which is R is equal to R naught A raised to power 1 by 3. This we have done in the topic E3, and everything is uploaded on the YouTube channel. By the way, you become the member, you watch the videos on the topic E3, and you already have this knowledge there. Okay, so R is equal to R naught A raised to power 1 by 3. From there, we want to find the density of the nucleus. Now, density is written as the mass divided by volume. Now, what is mass? Mass is, like, you can say that there is, like, A is the mass number, total number of nucleons, and the mass of one nucleon is taken as m. So the mass here can be taken as m into capital A. And what will be the volume? Volume of the sphere will be 4 pi r cube. Now let us plug in these values here. So 4 by 3 pi, r can be written as this. So it will become r naught cube into A, because A raised to power 1 by 3, when cubed, 3 and 3 will get cancelled out. It will become A. Thereby, we can cancel the mass number. So you can clearly see that the mass number is getting cancelled from numerator as well as from the denominator. So there is no mass number dependency here. So the density of the nucleus becomes m, the mass of proton or the mass of neutron, which is almost same, 1.007276 something. And 4 by 3 pi r naught cube is also a constant. So m value can be taken as 1.007276 for proton. And if I'm not wrong, it is this much AMU for neutron. So approximately we can take a constant value for the mass of like the small value m here. And the r naught value is also a constant, 1.2 Fermi meter. Fermi meter means 1.2 into 10 raised to power negative 15 meter. That we can plug in here. So clearly m is a constant value which never changes. 4 by 3 pi in itself is a constant value. R naught is also a constant, which is 1.2 Fermi meter. Even that is a constant. So this value is giving you a constant value. It means the density of the nucleus does not change. I'm not remembering the exact value of the density, but it was a very huge density, kind of like 10 raised to power 27 something kg meter cube of the order, something of that kind, which is very, very high density. So that is the density of the nucleus. And accordingly, we can see that C will be the correct answer because the density of the nucleus is independent of the mass number. So C will be the correct answer. Okay, dear students, so this is how we do this question. All the best. Bye. Okay, dear student, let's see this question. This question is from the topic E2, which is very different, I would say, and it's very interesting, isn't it? The photoelectron is emitted when a photon of energy E is incident on the metal surface. The work function is given with phi. What is the maximum possible speed of the photoelectron as it leaves the surface? So directly it is the application of the photoelectric equation, which was given by Einstein in 1905, for which Einstein got the Nobel Prize in physics, isn't it? Okay, so let us write that equation here. So E is the total energy of the photon, which is HF, and this is equal to like the work function plus the maximum possible kinetic energy with the electron. What does this equation say? It says that a photon of the energy HF is incident on the electron. It hits the electron absorbs the same amount of energy. It uses a part of that energy as work function to jump out of the metal. So that is a constant value. It will be used. So this much of the value is the minimum energy that photon need to provide to the electron so that the electron jumps out of the metal first of all. So this is work function, which is minimum energy required for the electron to jump out of the metal. Now, what about the remaining amount of energy? The remaining amount of energy will be HF minus phi, or you can even write E minus phi because they are not substituting the E as HF here. So I can just write E minus phi is equal to maximum kinetic energy. So it will be the mass of electron because it is electron which is moving. This is the maximum velocity that will be gained by electron. From there, you can just create the expression. So twice of E minus phi divided by the mass of electron, square root of that will be V max. So this is how we do it. So 2 E minus phi divided by ME square root. So A will be the correct answer. This is how we do this question. Okay, so nothing much to note here. By the way, the topic is already uploaded on the YouTube channel. You can check the playlist and watch the lectures. All the best. Bye. Okay, dear student, let's see what is there in this question. In a Compton scattering experiment of the photon of the wavelength lambda naught and frequency f naught interacts with an electron. So there is a photon and it was having a wavelength of lambda naught and the frequency of f naught before striking the electron. So there is like the photon is going, there is an electron which is placed in the path that photon is traveling. So lambda naught and f naught is this. After interaction, the wavelength and the frequency changes to lambda and f. It means like it goes here and then it gets scattered. So now the frequency becomes lambda and f. So of course electron will be pushed into some other direction. So the deviation or the scattering angle for the photon, it will be this, like you can take it as theta. The formula for the Compton effect is present in the data booklet. So if you don't remember it, you can always refer to the data booklet, no problem with that. Now, the question is, what is lambda by lambda naught? And what is the ratio of lambda into f divided by lambda naught into f naught? Wow, that's quite innovative question from Compton scattering effect. Like I was not expecting this kind of a question, by the way, but still not very difficult. Listen to this. There is a concept here. Lambda naught is the wavelength, and it is coming, the photon is got to have some energy, so that will be h into f, which can be written as hc by lambda. And when it is striking with the electron, some energy is given to electron. Some energy is given to electron. So electron has taken some kinetic energy from the photon. It means that photon is now having lesser energy. So energy for this photon, which is E2, HF2 or HF, it is lesser. So Hc by lambda, and this is Hc by lambda naught. This is more and this is less. It means Hc by lambda naught is bigger than Hc by lambda. Hc and Hc gets cancelled out. Cross multiply both sides. Lambda is greater than lambda naught. So lambda divided by lambda naught will be greater than 1. So no surprise about it. So it will be greater than 1. This is how we do it. We compare the energy, that the energy has gone to electrons. So the other photon is having a lesser energy, and you have created this thing. Now, this second part is quite innovative. Let's see. Lambda f. Now, what is this lambda f? V is equal to lambda f. Velocity is equal to f lambda, isn't it? So we are literally referring to the velocity of the photon without changing the medium. So even earlier the photon was in air, it was traveling in air, and even now the photon is traveling in air, so the medium is not changing. Photon is light, so the speed of light cannot change. It will always remain the same. So the product of lambda into f is the velocity of the light photon before collision divided by the velocity of light after the collision, which is never going to change. It means that this is equal to 1. When does the velocity of light changes? It changes only if it is moving into some other medium, that we have done in the topic E3, Snell's law, that when the light which is traveling in the air is entering into water, the speed will change. Other than that, other than refraction, other than Snell's law, there is no case in which the speed of light is going to be different from the normal speed of light, that is 3 into 10 power 8. So no doubt about it, the answer will be A. This is how we do this question. Thanks for watching the video. All the best. Bye. Okay, student, let's see what is there in this question. 3 products of radioactive decay are alpha particles, beta particles, and gamma photons. Which products can be deflected by both magnetic and electric field? So magnetic and electric fields will be able to deflect the charged particles. So alpha is a charged particle, beta is a charged particle, gamma is not charged. So 1 and 2 will be the answer. A will be the correct answer. What is alpha? Alpha is the helium nucleus. It's kind of like you have taken 2 electrons away from helium. So helium is having 2 protons, 2 neutrons, and 2 electrons. Electrons have been taken away. So it's only the nucleus of alpha. What is beta particle? Beta particles are of 2 types, beta minus and beta plus. Beta minus is essentially an electron, and beta plus is positron. So the complete topic of E3 is uploaded and the playlist is ready. You people can watch the lectures for that topic too. Okay, dear students, all the best. Thanks for watching. Bye. Okay, dear student, let's read this question. A nucleus of nuclide X decays. Which series of emissions will produce an isotope of the same element X? So you want to have the same isotope, like the same atomic number. That is what is isotope. What is an isotope? So the proton number should be the same. Like for example, uranium 23892 and uranium 23592. So the proton number should be same. That should not decrease or that should not increase. So whenever a radioactive decay is happening, in alpha, the atomic number reduces by 2. It means to say, like, it is already becoming Z minus 2. So instead of 92, it will become 90 atomic number. We are not concerned with the mass number. That is why we are not showing the mass number here. So the atomic number changes by 2 and it becomes 90. But then you have to increase the atomic number by 2. So you would be using 2 beta particle, that is of no doubt. 2 alpha is definitely out of question, because if there will be 2 alpha, the atomic number reduces by 4. You would be needing 4 beta particles to compensate for that. And that is not in the option. So C and D are definitely wrong. Now it has been reduced by 2. So there are 2 types of beta particles. One is beta minus, another is beta plus. Beta minus, when beta minus is there, or like electron is emitted from that, the atomic number increases by 1. And when the positron is emitted, the atomic number is reduced by 1. Clear? So we want to increase the atomic number by 2. So you would be needing 2 beta minus. So A will be the correct answer here. Sure, there is no problem with this. So this is how we do it. Always remember, in beta minus, atomic number increases by 1. In beta plus, atomic number decreases by 1. All the best. Bye. Okay, student, let's go for this question. A suitable material for use as a moderator in a nuclear reactor is. First of all, this topic is the topic E4. in which we are learning about the nuclear fission and the nuclear fission reactors. Two things are very important in nuclear fission reactor. What are they? Number one, the moderator, and number two is the control rods. So if you are learning those things, yeah, so concentrate more on these two things. Now let me come to the moderator. Moderator is the fluid kind of a thing, like with which the complete reactor is filled. The purpose of a moderator is to slow down the speed of the neutron so that when the neutron strikes the uranium atom or the uranium nuclei, then it does not bounce off from it. Because it is having a very high speed, there are chances that it will collide with the uranium, but it will not be seized by uranium nucleus. Might be that the neutron is going to bounce off. To reduce those bouncing off of the neutron from the uranium nucleus, what we need to do is slow down the neutron a bit. So we will slow it down with the help of the moderator. What is the mechanism? The moderator molecule is going to collide, like this is non-reactive completely. It is going to collide with the fast moving neutrons. This is given some, like it is pushed off to some other side. So this moderator molecule, which earlier was not moving, it was having zero kinetic energy. Now some energy has been taken by the molecule of moderator. It means that neutron is now having lesser kinetic energy, which means that neutron is now slowed down. So this neutron is the perfect neutron, and this neutron can cause the nuclear fission reaction. It can be seized by the uranium. Clear? So this neutron, yeah, this is the purpose of moderator. Now, so moderator will be essentially liquid. Usually it is either the ordinary water, or you can use heavy water, that is D2O, by using deuterium. It is known as heavy water. Heavy water is very popular as a moderator, very popular. Well, as an Indian, I can tell you the first nuclear reactor to India, that was actually given by Canada to India. And the name of that nuclear reactor was Cyrus. And that nuclear reactor was using D2O as the heavy water. Now that nuclear reactor has been decommissioned, by the way, because it was very old, like kind of like 1970s or 1980s, probably. I'm not remembering the date. So that was the time, I think 1971, yes, when this nuclear reactor was given. Anyways, sorry for wasting your time. So either you use the ordinary water, or you use heavy water, or you go for graphites. In many nuclear reactors, even graphite is used as moderator. That might be a surprise because graphite is a solid. Okay. Apart from that, like usually these three are used as moderator. We've, of course, when we can use water as the moderator, why we would be looking forward to some other material? First of all, there are other material also that you can use. Beryllium, you can use hydrogen, deuterium. But anyways, usually we use these three. Okay. And concrete, of course, cannot be used because it is completely solid. Cadmium, I'm coming to cadmium. Uranium cannot be used. Uranium itself is a fuel, but uranium 238 is naturally occurring uranium, which is different from uranium 235, which is nuclear grade. So you are using uranium 235 as the nuclear fuel. Uranium 238 is the raw uranium that you find in Earth, and this is radioactive, but it is not good for nuclear fission. So there is no purpose of using uranium 238 there. So even this is out of option. Concrete is out of option. Cadmium is a curious case now. Cadmium is a material that absorbs neutrons. So do not get confused. Cadmium is the material which is used in control rods. Control rods. It is used to absorb neutrons. So if you want to slow down the reaction, you want to absorb the neutrons to, convert the uncontrolled fission reaction into controlled fission reaction, you use control rods. If you want to decommission a nuclear reactor, as I told you, so you would be using the control rods. You press the control rods completely, it is going to absorb all the neutrons. So cadmium is used in control rods, but not as the moderator. So even A is wrong. D is the right option. Okay, dear students, thanks for listening to me. This is Professor Varun. All the best. Bye. Okay, dear students, let's see what is there in this question. In a simple model of nuclear reactor, 4 neutrons are emitted per fission on an average. Okay, usually it absorbs 1 neutron and it produces 4. That's kind of explosive material. Okay, the average number of neutrons absorbed by the control rod is given as NC per fission. So out of these 4, NC number of neutrons are absorbed by the control rod. Average number of neutrons that are lost through the wall is N1 per fission. So that's the new thing. The neutrons are getting lost in the wall. So N1 is also lost from these 4. Remaining neutrons, they induce further fissions. What are the possible values of NC and N1 for the reactor to maintain a steady reaction? So the crux here is that out of these 4 neutrons, actually you would be needing only 1 neutron to create a steady reaction. Okay, so it will be consuming 1 neutron and you would be providing 1 neutron kind of case. Out of 4 neutrons, you just need 1 neutron. It means you have to take away 3 electrons from it. So we have to choose the option where the sum total of NC and N1 should be 3. And that is sufficient, I believe. Like that could be giving you the answer. 1 and 1 is 2. 1 plus 3 becomes 4. 2 plus 1 is 3. 2 plus 2 is 4. So as I told you, that will be one of the cases. So C becomes the perfect example of perfect question here. So for the steady reactions, the sum total of NC and N1 should be 3, so that there will be only 1 neutron that will be remaining. Okay, dear students, so this is Professor Varun. This is how you do this question. All the best. Bye. Okay, let's see what is there in this question. A star has a parallax angle of 10 raised to power negative 2 arc second at the orbit of the Earth. What is the distance from the Sun to the star? Okay, so this is one of the least expected question from IB, honestly speaking. And if they've asked this question, it becomes very difficult for us to do this, Okay, so as a matter of fact, the topic is uploaded in the topic E5 for the lecture series that I have uploaded. You have to become the member to watch it. And the topic of parallax is completed there. Okay, like completely it is given there if you want to see it. Although we would be discussing everything here, don't worry about it. Now, so first of all, we have to understand what is parallax. And then we would be able to do this question. This question can be divided into 2 parts. Number 1 is what is parallax and what is parallax system. We don't understand anything. So we have to first understand that. Second part is the application of the concept. And even that will be having too many things where we can make some or the other kind of mistakes. So it's very important for us to concentrate here and learn what is happening. Let's see that, let's say this is the sun. Like I'm drawing it very small, so there is a reason for it. And this is Earth. So first of all, we will see like, yeah, the distance between the sun and the Earth. This distance is 1 astronomical unit, but I am taking it as D. And from the center of it, like there is a star which is at a very large distance. It is measured from the center of this distance. Let's say this is the star here. And you want to find like this star is A. This is the sun. So I'm writing it as S. And this is Earth, E. So what we do is we want to find this distance. This is X, the distance of the star from our solar system, you can say from the Earth Sun system. And because the star is very, very far away, so it hardly matters whether you're taking distance from this point or you're taking distance from the sun itself, because the distance is very huge and very large. Let me tell you what is the extent of that. Now this is 1 AU. So what is 1 parsec? So 1 parsec is the distance, like this X value will be equal to 1 parsec if the angle subtended by sun and Earth at that point, at this point, like this. So the total angle subtended here, of course, it will have some value. But when this angle becomes equal to 1 second, the distance is known as 1 parsec. Now you would be asking, what is 1 second? 1 second is, we are not talking about the time here. like 1 degree, and then there is something called 1 minute, and then there is something called 1 second. 1 minute is defined as 1 degree when 1 degree is divided into 60 parts. So one part is 1 minute. That is that small. And what about 1 second? You further divide 1 minute by 60. So overall, 1 second can be written as 1 degree divided by 3600 parts. So you just imagine like 1 degree is very small angle, and even then you are dividing it into 3600 parts further. So that small angle has to be subtended at the star, and the distance on this axis here, it is very, very large, which is from sun to earth, kind of like 1 astronomical unit, and the value is 1.510 raised to power 11 meters. No doubt that 1 parsec is having the largest ever value possible. So 1 parsec is kind of the largest unit for length. Indeed, isn't it? That is really a largest unit. So this is what is parsec. So now let us talk about the theta here. Let's say this total angle is theta. I can always write this tangent theta as, now theta is very, very small, so it doesn't matter whether the line is joining at this point or the line is joining at the sun, because angle is quite small, like this. So this angle will be approximately equal to this angle, so it doesn't matter. So we can take this tangent theta as this distance divided by the total distance, which is equal to x, and this distance is equal to d. Of course, d is equal to 1 astronomical unit, but I'm just using the word d here. So tangent theta can be written as d by x. This is the formula that we will be employing in our question here. Now come to the topic. So going to maths AA, a bit of more knowledge. When theta is tending to 0, tangent theta can be approximately written as theta. So I am just going to remove the tangent here, and I will just write theta. So case 1, when we're talking about 1 parsec, so theta is equal to, the d value will be 1, or I can just keep it as d, and x is written as 1 parsec, and this theta will be written as 1 second. Now this 1 second can also be written as 1 divided by 3600 degree, as it is written here. So I am just writing here. So d divided by 1 parsec, which is distance, is equal to this. Please don't mess up around with the units. Be very careful. Now we're moving into case 2. Like, what is the scene here? The scene here is that the angle is 10 raised to the negative 2, so 0.01. So which can be approximated equal to theta. So theta now will be 10 raised to power negative 2 second. D is going to remain D, but the distance is not known. So this distance x in the second case is not equal to 1 parsec. We don't know what value is it having. So we are just going to keep it as x. Now this second can be converted into degrees. By dividing this value by 3600, I can just write it as degrees. Now I am going to concentrate on this and this, and we have to solve it for x. So we get the value of d and we substitute the value of d here. Let us do it. So d, 1 parsec goes to the other side. So I can, d in place of d, I can write 1 parsec multiply by 1 divided by 3600. This is the value of d divided by x will be equal to 10 raised to power negative 2 divided by 3600. 3600 and 3600 gets cancelled out. X is going to the other side and this is going to the other side. Then again the reciprocal. Clearly we can solve it, and x is coming out to be equal to 100 pc. So D will be the correct answer. So the distance of the star from the sun or from the earth or from the sun-earth system, because they're all approximately same, so that distance will be calculated as 100 parsec with the help of parallax method, which may or may not be exact, practically speaking. Like, what is the actual distance of the star, we don't know, but the method that is suggested, which is known as parallax method, if we follow the method given by scientists like this method, then the star should be at 100 parsec distance. Practically, which may or may not be same, it might be different, but according to this method with all its limitations, what the value that we get is 100 parsecs. So this is how we do this question. Probably, I believe every concept is clear. The lecture for this is already uploaded on YouTube channel. You have to become the member to watch that series, and then you can learn this even better.